Imagine the night sky is not a permanent backdrop, but an immense, dark ocean, and we, on our small blue marble, are simply waiting for a vessel to cross our harbour. Most of the travellers we see are local, familiar ships made of rock and ice, born of the solar system's own construction, but occasionally an object arrives that was forged elsewhere, having journeyed for billions of years between the silent, unlit continents of the galaxies. Comet 3I Atlas was one such visitor, an interstellar wanderer detected as it plunged toward the gravitational well of our star. On the 2nd and 3rd of October, the Mars Reconnaissance Orbiter, our dedicated sentinel hovering near the red planet, captured the most detailed images of this relic we would ever obtain. Its camera possessed 3 times the clarity of the famous Hubble Space Telescope at that distance, promising a breathtaking, high-definition look at something that originated far beyond the reach of our own sun. Yet, for 43 days, that data sat in a silent server, untouched and unreleased, hidden behind a sudden, convenient veil of administrative paralysis known as a government shutdown, while the world's scientific community paused its breath, waiting for the definitive evidence that would either validate or utterly demolish their theories. The official narrative crumbled, not in a dramatic explosion, but in the slow, quiet trickle of images coming from backyards across the world. These were not billion-dollar telescopes, but consumer-grade equipment operated by dedicated amateur astronomers, people like Michael Jagger and Gerald Riemann, who were capturing details that NASA's mighty orbiter would fail to show the public. They documented 7 distinct jets of material firing from the object's core. This is the subtle paradox that should quiet your mind and sharpen your curiosity. Some jets pointed away from the sun, which is normal for a comet's outgassing, but others pointed directly toward our star, seemingly fighting against the immense outward pressure of solar radiation and solar wind. What if this complex structure, this intricate pattern of 7 directed beams, wasn't the result of random ice sublimation, but something far more deliberate? What if what looked like a comet acted like a comet in most ways, but refused to obey the fundamental laws of physics we apply to natural, icy bodies? We are looking at a story of observation and obfuscation, a mystery recorded by an interstellar visitor that demanded answers our institutions seemed unwilling to give. Leave a comment telling me what time it is and where you are listening from tonight, and whether you think NASA's silence was simply administrative. Because in the vastness of the cosmos, where the light stretches like silk across the void, sometimes the deepest truths are hidden not by the darkness, but by the intentional dimming of the light. And that quiet delay, that 43-day blackout, may have been hiding something far more significant than a government dispute. The true nature of an object is often revealed in its motion and its timing. This is a story about the deliberate, measured passing of 43 days, a period of silence that speaks volumes about institutional priorities when faced with an unprecedented celestial event. We must quiet our minds and remember the stakes. Comet 3I Atlas was not just another rock in space. It was a traveler from another star system, one of only 3 such objects we have ever detected. Its close approach to our sun, known as perihelion, was the single most critical observation window, the moment when solar heating would trigger the most intense outgassing and, critically, reveal any anomalous behavior. The Mars Reconnaissance Orbiter was our only eye in that moment, positioned perfectly while the Earth was inconveniently on the opposite side of the Sun. It captured its high-resolution images on the 2nd and 3rd of October, when 3I Atlas was a mere 29 million kilometers from the red planet, a close-up we would not get again for perhaps millions of years. For 43 days, that vital, time-sensitive data, the one piece of evidence that could have settled the debate between natural object and technological artifact, sat quietly on a server, locked behind what NASA claimed were bureaucratic protocols triggered by a government shutdown. But let's look closer at that explanation, that seemingly simple claim of furloughing staff and suspended non-essential operations. The International Space Station remained fully crewed. Deep space missions continued to transmit telemetry, and the mighty James Webb Space Telescope maintained its operational schedule. The mechanism of the shutdown, which began just one day before the high-rise images were captured, felt less like an unfortunate coincidence and more like a calculated, if accidental, veil. Dr. Avi Loeb, a Harvard scientist known for his unconventional thinking, called the delay a kind of terrestrial stupidity, not evidence of alien intelligence, but proof that human bureaucratic incompetence could hold hostage the most profound scientific discovery of a generation. The delay meant research teams missed proposal deadlines for telescope time, unable to justify their requests without the foundational Mars data, and international collaborations stalled. The American piece of the puzzle intentionally withheld, while the institutions remained in their carefully constructed silence. The vacuum was filled by speculation, by conspiracy theories, suggesting everything from the detection of techno-signatures to a coordinated effort with military intelligence agencies to assess potential threats. This is the central tenet of narrative control. When you withhold information during a moment of intense public interest, you create the perfect environment where wild speculation, or even profound truth, can thrive unchecked. When the images were finally released on the 19th of November, the accompanying press conference was a masterclass in managing expectations, emphasizing normalcy, and confidently dismissing any speculation of artificial origin. The fuzzy, smeared high-rise image shown by NASA conveniently obscured the fine details that could have settled the debate. The light appeared smeared due to what was called spacecraft jitter during the observation period. The effect was to render any complex surface features invisible, presenting the object as nothing more than a bright glow in the darkness, and inviting the public to simply take the official word for it. It was just a comet. But you must understand this. Time is the currency of astronomy. When an object is moving at 246,000 kilometers per hour through the inner solar system, every day, every hour, matters. The delayed release gave NASA exactly what it needed: time. Time to craft a unified, controlled narrative. Time to coordinate messaging across multiple missions. Time to emphasize the normal and strategically downplay the anomalous. This was not merely a data release. It was what has been described as damage control, disguised as transparency. The fundamental question remains: why did the most important data set from the most rare astronomical event in modern history require 43 days of bureaucratic processing? When amateur astronomers were publishing their verifiable findings within hours of capture, the European Space Agency, China's space program, Japan's, they all continued to operate. only American federal agencies went dark, creating a blind spot at the most critical phase of the object's passage through our solar system, a gap in the data we can never recover. The 43-day silence was not about a government shutdown. It was about control, and what that silence revealed about institutional priorities was far more unsettling than anything 3i Atlas might actually be. We have now entered the domain where observation challenges authority, where a backyard telescope can overturn a billion-dollar narrative, and this quiet contradiction is where our journey truly begins. We turn our attention now to the amateur astronomers, the quiet heroes of this strange, celestial encounter, who, working with equipment you could order online, captured an image that shattered the illusion of normalcy. The core observation, captured by astrophotographers Michael Jagger and Gerald Riemann in Namibia, stacking 24 exposures through a simple green filter, revealed not a smooth, fuzzy ball, but a complex network of at least 7 distinct jets. A typical comet's activity, the simple outgassing expected from sublimating ice, should produce a relatively uniform glow around the nucleus, perhaps a directional bias pointing away from the intense solar radiation. What you should absolutely not see are multiple, discrete streams of material firing in completely different directions simultaneously. And yet, that is precisely what they saw. Some jets behaved as expected, pushing away from the sun, but others, the so-called anti-tails, pointed directly toward it, in a clear, persistent violation of almost every known law of cometary physics. To understand the profound strangeness of this, we must briefly consider the environment. The solar wind, a stream of charged particles flowing from the sun at approximately 400 kilometers per second, and solar radiation pressure, the immense momentum carried by light itself, both push material outward. This is why a comet's tail always points away from the sun, regardless of the comet's direction of travel. But 3i Atlas was actively and persistently breaking this rule. Material was streaming toward the sun, fighting against the solar wind for a distance of nearly 1 million kilometers. Dr. Avi Loeb, applying the physics we know, calculated the sheer impossibility of this, for that anti-tail to remain visible across 1 million kilometers against the solar wind's pressure. The mass density of the outflow would have to be roughly 1 million times greater than the surrounding solar wind itself. That immense density translates to a staggering mass loss rate, comparable to conservative estimates of the object's total mass. For a natural comet losing mass at such an aggressive, almost suicidal rate, you would expect to see a massive, expanding debris cloud, structural fragmentation, and dramatic brightness surges. But the later images showed 3i Atlas remaining remarkably compact, almost as if the mass loss was being controlled and directed, not passively vented. Now, layer in the issue of rotation. The light curve analysis conducted months earlier had established that 3i Atlas spins with a period of 16.16 hours. If material is sublimating from ice pockets on a tumbling nucleus, those jets should logically spiral, creating a pattern like the spray from a spinning lawn sprinkler. Yet, the jets appeared as straight, columnated beams, extending millions of kilometers, maintaining their orientation as if something was actively compensating for the tumbling motion of the core. This is the crux of the problem. We have 7 jets of material, defying solar pressure, maintaining focus across vast distances, and refusing to spiral despite the object's rotation. Each anomaly, viewed in isolation, might have a complex natural explanation, such as Dr. Loeb's proposal of ice pockets hidden deep in surface valleys, only exposed to sunlight at precise rotational phases, creating short-lived, pulsed jets that look continuous from far away. But for all these conditions, deep valleys, specific rotational alignments, extraordinary mass density, and a simultaneous appearance of 7 distinct jets to occur naturally on a random interstellar traveler, the odds become vanishingly small. The alternative interpretation is not one of nature's elegant complexities, but of engineering simplicity. 7 is a reasonable number for thrusters arranged around a spacecraft designed for trajectory adjustment and 3-axis attitude control. And the jet's prominence at perihelion, the closest approach to the Sun, is exactly when you would fire engines to perform a gravitational assist, maximizing the efficiency of your propulsion. The timing is consistent with both a technological adjustment and a natural peak in cometary activity, but the structure favors one interpretation more than the other. We are left not with definitive proof, but with an accumulation of evidence that challenges our deepest assumptions, forcing us to reconcile the possibility that what we are seeing is either a comet with features that push the very boundaries of known physics, or a technological object that has mastered the art of camouflage. The journey continues, now with a distinct question hanging in the air. What is powering those 7 impossible beams of light and material? As we move deeper into the mysteries of 3I Atlas, we encounter a chromatic contradiction, a quiet glow of a specific wavelength that science understands, yet which the object should not be exhibiting. The observation, made by observers like Zhang at Lowell Observatory, noted that 3I Atlas was glowing a distinct green on the 5th of November. This was not the expected blue-white of scattered sunlight or the yellow-orange of dust, but a specific color that, in the context of comets, tells astronomers something precise: the presence of diatomic carbon. Diatomic carbon, or C2, is the classic, expected culprit. When the sun's powerful ultraviolet radiation strikes this molecule in a comet's coma, it fluoresces brightly in the green part of the spectrum. It is a normal, reliable signature that helps distinguish comets from asteroids, a signature seen in most comets originating from within our own solar system. Yet, here lies the next great anomaly. Despite multiple, exhaustive spectroscopic analyses from the James Webb Space Telescope, the Hubble Space Telescope, and various ground-based observatories, no diatomic carbon was detected. You see the problem. The object is glowing green, but the chemical that reliably causes the green glow is absent. Spectroscopy is our most trusted chemical detective. It should have revealed the molecule's distinct absorption and emission lines. Its repeated failure to do so suggests either a profound limitation in our detection methods, or that something else entirely, through a mechanism we have not yet identified, is producing the visible green emission. Dr. Avi Loeb suggested an alternative, such as cyanide, which had been detected in the coma by the Very Large Telescope in Chile. Cyanide compounds can produce greenish emission under certain conditions of solar radiation, and 3I Atlas already showed an unusual chemical abundance of carbon dioxide and elevated nickel emissions without corresponding iron. Perhaps the object's chemistry, forged around a different star and altered by billions of years of interstellar travel, follows different rules than our local, familiar comets. The green glow appeared stronger as the object emerged from perihelion, logically suggesting a connection to intense solar heating and subsequent outgassing activity. However, the green coloration was not uniformly distributed across the coma. Observers noted patches of stronger emission, a variation in intensity that implies the source molecules are not evenly spread, as you would expect from simple solar heating of surface ice. This patchy distribution hints at a complex surface topology with specific, highly localized active regions, or perhaps an inherent chemical heterogeneity within the nucleus itself. Scientists noted the puzzle explicitly. The green glow exists. The molecule that causes the green glow is absent. Therefore, either our methods are missing something fundamental, or our century-old understanding of cometary coloration is incomplete. This inability to explain a feature as basic as its color adds another data point to the growing list of ways 3I Atlas refuses to conform. The missing diatomic carbon, the anomalous elemental ratios of nickel and iron, the unusual carbon dioxide abundance, the 7 complex jet structures, the anti-tail configurations, each one is a small deviation. But when they accumulate, they suggest a pattern, a fundamental distinction between this object and the comets we have grown so comfortable with. The green glow is telling us something about the object's composition and how it responds to the energy of our sun, a message we have not fully decoded. One final, uncomfortable possibility is that the green emission is not coming from the thin, tenuous coma at all, but from a surface phenomenon. If certain minerals or compounds on the nucleus's exposed areas reacted to solar radiation, the fluorescence would originate from the solid material, not the gas phase molecules, which would neatly explain why spectroscopy of the gas-filled coma has come up empty. This ties back to the anomalous composition, suggesting a chemically distinct formation environment. The persistent green light, confirmed by multiple independent observers throughout November as 3I Atlas moved away from the sun, is not an artifact. It is an undeniable, persistent phenomenon that continues to challenge assumptions we didn't even realize we were making about how an interstellar traveler should behave when it arrives in our neighborhood. The mystery of the green glow is not just a scientific curiosity, it is a quiet, elegant challenge to our entire cosmic worldview. The story of 3I Atlas continues to center on the laws it refuses to obey, chief among them the universal command of solar radiation pressure. Solar radiation pressure, the force exerted by light carrying momentum, and the solar wind, the relentless stream of charged particles flowing at 400 kilometers per second, are two of the cosmos's absolute commanders. They push material away from the sun. They shape the tail of every known solar system comet, stretching it across millions of kilometers of space. This is the rule. Yet, 3I Atlas, with its material streaming toward the sun in multiple, distinct jets, its persistent anti-tails, is engaged in a direct and sustained confrontation with these forces. This is no subtle effect or minor deviation. It is material flowing in the diametrically opposite direction from every force acting upon it, persisting across distances where those forces should be overwhelmingly dominant. To grasp the energy required for this defiance, we look again to the calculations. Dr. Avi Loeb's analysis suggests that for the anti-tails to maintain a visible density up to 1 million kilometers from the nucleus, their density must be approximately 1 million times greater than the surrounding solar wind. Most comet tails thin out rapidly, dropping to near vacuum densities a few 100,000 kilometers from the core. 3I Atlas is holding coherent, dense jet structures for an order of magnitude further out. The sheer energy needed to accelerate material to velocities that allow it to penetrate sunward against the solar wind is staggering. Natural sublimation of ice provides exhaust velocities around 400 meters per second, which is adequate for a conventional tail being pushed by the solar wind, but it is nowhere near enough to fight back against a force that is moving at 400 kilometers per second. You would need exhaust velocities comparable to, or even exceeding, the solar wind itself, hundreds of kilometers per second. This is the velocity domain of rocket engines, not passive thermal outgassing. The search for a natural explanation quickly enters the territory of optical illusion or highly improbable dust dynamics. Perhaps it is merely a projection effect, where jets moving perpendicular to our line of sight appear to point sunward because of a specific viewing geometry. This happens occasionally with comets, but it requires a remarkable coincidence. Crucially, the anti-tail signature of 3I Atlas persisted across observations from different vantage points, including the Mars Reconnaissance Orbiter and Earth-based telescopes, suggesting the jets truly are pointing sunward in three-dimensional space. Another natural hypothesis centers on exceptionally heavy dust particles, less affected by solar wind because of their higher mass-to-area ratio. These massive grains might retain enough initial momentum to travel sunward for a time before the solar forces eventually slow them down. However, this explanation struggles with the vast distances involved. An anti-tail extending 1 million kilometers would require a continuous, massive ejection of particles over weeks or months, depleting the nucleus at an unsustainable rate. The anti-tails were tracked by projects like the Virtual Telescope project through mid-November, continuing to persist even as the object moved away from the sun and solar heating decreased. This duration and persistence defy the expected rapid diminishment of natural cometary activity. We are left with the uncomfortable, yet physically sound, alternative. If the jets represent the exhaust from a propulsion system, the anti-tail configuration makes perfect sense. To adjust a trajectory toward the sun, an object must fire its thrusters away from the sun. The exhaust naturally flows sunward, while the spacecraft accelerates in the opposite direction. Because rocket exhaust velocities can be tens or hundreds of kilometers per second, the plume can easily penetrate deep into the solar wind before dispersing. This timing is also consistent with the perihelion passage, the closest approach to the sun, which is the moment of highest orbital velocity, making it the most efficient time to burn engines and maximize the energy gain from a trajectory correction, a concept known as the Oberth effect. Every piece of evidence, the persistence, the density, the velocity requirements, the timing is perfectly consistent with a technological maneuver. While every single anomaly can be explained away by stacking one low-probability natural event upon another complex geology, heavy dust, electromagnetic, focusing the accumulated pattern suggests a kind of coherence, an intentionality that transcends random chance. The anti-tail physics matters because it presents a clear, testable prediction. Spectroscopic observations planned for mid-December as 3I Atlas makes its closest approach to Earth, should be able to definitively measure the velocity and temperature of the material. If the material is natural sublimation, the velocities will be slow. If it is rocket exhaust, they will be tens of times faster. The data, when it arrives, will either confirm the conventional comet hypothesis or challenge it with a finality that requires no further philosophical musing. The narrative of 3I Atlas shifts now from the quiet, dark space of astronomical observation to the brightly lit, politically charged halls of Washington, D.C., where a single voice demanded accountability. That voice belonged to Representative Anna Paulina Luna, a congresswoman who, though not a scientist or astronomer, possessed a fierce reputation for asking uncomfortable questions and refusing to accept bureaucratic deflection from federal agencies. When NASA held the vital high-resolution images from the Mars Reconnaissance Orbiter for more than a month, citing government shutdown procedures as the primary cause, Representative Luna decided that the explanation was inadequate. Her formal letter to the interim NASA administrator was not a polite, diplomatic request, but a direct demand. She insisted that the high-rise images be released immediately, along with all supplementary data from other missions that had observed 3I Atlas during its perihelion passage. And, crucially, she demanded an explanation for why time-sensitive scientific information was prioritized below administrative protocols. Her intervention was significant because it applied public pressure. By framing NASA's delay as a failure of scientific accountability, a failure for the American public to know about an unprecedented event, she changed the calculus. Agencies respond differently when they are operating in the harsh light of a public spotlight versus handling routine correspondence behind closed doors. Her request extended beyond the Mars images, demonstrating an informed understanding of the astronomical campaign. She asked for data from the Parker Solar Probe, readings from the Juno spacecraft at Jupiter, and any relevant observations from the Hubble and James Webb space telescopes. Most intriguingly, she explicitly invoked the Center for Near-Earth Object Studies, or CNOS, database of interstellar meteors, demanding transparency about known discrepancies in that catalogue. This reference connected the current delay to a broader pattern of withheld or poorly communicated data regarding objects from outside our solar system. She was implicitly referencing a meteor that entered Earth's atmosphere in 2014, with a velocity suggesting an interstellar origin, data on which had remained classified because it originated from military sensors that monitor for nuclear test signatures. Representative Luna was directly confronting the bureaucratic obstruction that had previously limited the scientific community's access to vital data. Her timing was impeccable. She sent the letter while the government shutdown was still active. This placed NASA in an impossible political bind. Either they had to admit they could, in fact, release data during a shutdown and had simply chosen not to, or they had to maintain the position that federal protocols genuinely prevented them from sharing information about the most significant astronomical event in recent memory. Neither option looked acceptable. When the shutdown finally ended, the response came almost immediately, confirming that NASA had committed to releasing the images and data. Representative Luna framed this as a victory for transparency, a clear demonstration that political pressure could compel agencies to prioritize scientific communication over bureaucratic inertia. The core revelation of this exchange was not merely the image release, but the tacit acknowledgement that the shutdown had not prevented the data processing or corrupted the files. The data was ready. The shutdown provided political cover for a deliberate delay, a precious period of time used to prepare a comprehensive, coordinated, and reassuring public response to the speculation surrounding 3I Atlas. Lunar's intervention stripped away that cover, making the delay itself the story and forcing NASA to justify the withholding of information. Her request was highly specific, asking for particular observations from particular instruments at particular times, which made it impossible for NASA to offer vague promises of future releases. She also artfully invoked planetary defense, noting that refining the trajectory of any object passing through the inner solar system had long-term implications for our ability to track future potential threats. Withholding data that could improve our trajectory, prediction models was, in a sense, compromising planetary safety. This reframing elevated the debate beyond alien speculation and grounded it in practical, security-focused concerns. The congressional intervention created a vital precedent for future events. It demonstrated that political pressure can be leveraged to enforce transparency, ensuring that the public's right to information about astronomical discoveries is not ignored. Whether NASA would have eventually released the data without the letter is debatable, but the speed of their action once the letter became public suggests that the political incentives had fundamentally shifted. This moment, where politics and science intersected, ensured that the critical information about 3I Atlas was made available weeks earlier than might have otherwise occurred, providing a temporary victory for open science over institutional caution. We return now to the physics of the nucleus itself, to the subtle contradiction between the object's known rotation and the observed, unspiraled geometry of its multiple jets. In July, before the spectacle of perihelion, light curve analysis revealed that the nucleus of 3I Atlas was tumbling, completing one full revolution every 16.16 hours. This is the expected behavior of a comet. As it spins, different surface features reflect light at different angles, causing the brightness to vary periodically. The problem arises when we overlay this known rotation onto the now famous jet images. If a source is continuously venting material while spinning every 16 hours, the resulting output should trace a distinct spiral pattern, much like water spraying from a spinning lawn sprinkler. The material leaves the nucleus and continues on a straight path, but the source of the material rotates, and the combination of these two motions creates a visible curve. This is basic kinematics, first-year physics, yet the images from amateur astronomers show the jets extending across millions of kilometers as straight, columnated beams with no discernible spiral structure. At the typical sublimation velocity of 400 meters per second, it takes material approximately 1 month to traverse 1 million kilometers. During that month, 3I Atlas would complete roughly 45 full rotations. The material, vented at different times during those 45 rotations, should be distributed across a wide arc, creating a clear fan or spiral shape. The fact that we see narrow, focused beams instead represents the rotation problem. This mismatch requires one of 3 possibilities. Our understanding of the rotation must be revised. A mechanism must exist that actively compensates for the rotation. or the jets are simply not produced by the simple sublimation of surface ice. One natural possibility is that the rotation period has drastically changed. Asymmetric outgassing can create torque, acting like a tiny rocket engine that spins the nucleus up or slows it down. Comets are known to change their rotation rates, but asymmetric outgassing typically accelerates the spin. For 3I Atlas to slow down or completely stop its 16-hour rotation would require a remarkably specific and unlikely venting geometry jets positioned precisely to create a counter-rotational torque. A more elegant natural explanation, suggested by Dr. Avi Loeb, is the pulsed outgassing hypothesis. If ice pockets are buried in deep valleys, surrounded by mountains on the nucleus, they would only be exposed to direct sunlight for brief moments during the 16-hour rotation cycle. This would create a pulsed venting of material, short bursts of gas separated by approximately 16 hours. From a great distance, those individual puffs, separated by roughly 23,000 kilometers, might blend together, appearing as a continuous, straight, columnated beam. This works because each puff would be emitted when the specific surface feature points in the same direction relative to the Sun, ensuring all puffs follow the same straight trajectory. They do not spiral because the material is not being continuously emitted as the nucleus rotates. However, this explanation, while physically plausible, requires an extraordinary series of coincidences. It demands deep valleys, high mountains, and multiple distinct, active regions, 7 of them, in fact, all positioned with their own precise shadowing configurations to produce the multiple, different length jets that were observed. The probability of all these highly specific geometric and chemical conditions occurring naturally on a random interstellar object feels uncomfortably low. Furthermore, the jets were reported to maintain their structure and character across multiple observations spanning several days. If the jets were a pulsed phenomenon tied to rotation, we should expect to see them evolve and change shape visibly over timescales of hours. But observers noted a remarkable consistency in the jet patterns. The uncomfortable alternative is the technological interpretation. If the jets are the exhaust from propulsion systems, the problem of rotation disappears entirely. Thrusters can be gimbaled or pointed in specific directions, regardless of how the spacecraft is tumbling. Attitude control systems, a standard feature of any technological vessel, can maintain the alignment of the exhaust beams in a fixed direction relative to the trajectory, compensating for the core's rotation. This is trivial engineering for an interstellar civilization. But, again, accepting this requires acknowledging the possibility of non-human intelligence, a step most scientists are still unwilling to take, based on the rotation anomaly alone, preferring to propose complex, low-probability natural scenarios. The rotation problem, therefore, remains a profound piece of the puzzle. It forces us to question our most basic assumptions about how a tumbling object interacts with the material it vents, adding to the accumulation of anomalies, the green glow, the anti-tails, the 7 jets that make 3I Atlas increasingly difficult to categorize using standard models. The rotation problem, unresolvable from Earth-based observations alone, will continue to haunt the data until further, more detailed measurements are made. The unfolding drama of 3I Atlas created a clear dichotomy: the controlled, delayed narrative of the space agency versus the immediate, unfiltered observations of the global amateur community. Imagine the scene. Stuart Atkinson, an amateur astronomer in Kendal, Cumbria, setting up his consumer-grade C*S 50 smart telescope in the frosty darkness of 4:30 in the morning. He was one of many, a distributed network of enthusiasts across the world who refused to wait for official permission to look up, while NASA sat on the high-resolution data from the Mars Reconnaissance Orbiter for 43 days, citing administrative protocols. These individuals were pointing their equipment skyward and publishing what they saw within hours of capture, sharing their raw data freely on forums and social media networks. There was no peer review gatekeeping, no administrative approval required, only observation, curiosity, and rapid community sharing. Michael Jagger and Gerald Riemann did not wait for approval when they combined their 24 exposures to reveal the 7-jet structure. Frank Nebling and Michael Buckner followed swiftly, combining observations from 2 telescopes to produce even more detailed images. Their stacked images clearly showed the anti-tail jets extending nearly 1 million kilometers toward the Sun, and the conventional tail stretching almost 3 million kilometers in the opposite direction. Structures 1,000 times larger than what the Hubble Space Telescope had detected months earlier were captured from ground-based amateur equipment. This profound discrepancy should give us pause. The Mars Reconnaissance Orbiter, positioned 29 million kilometers from 3I Atlas, utilizing a camera that cost millions of dollars to develop and operate, produced a fuzzy, smeared image that revealed almost nothing of the object's core structure. Meanwhile, hobbyists, using equipment they kept in their garages and backyards, captured crisp, detailed views showing the complex, multi-jet configurations that fundamentally challenged the official narrative. This failure can be interpreted in 2 troubling ways. Either NASA's multi-million-dollar equipment and processing somehow dramatically underperformed compared to consumer-grade gear operating through the Earth's atmosphere, or the agency made a conscious choice not to highlight the structural details their superior instruments had certainly captured. In either case, it does not inspire confidence in institutional science. Stofan Morata added to this independent campaign from New Mexico, capturing the multiple jets, clearly visible both toward and away from the Sun, publishing his results with verifiable coordinate grids so that anyone with similar equipment could reproduce his observations. The amateur community, with its distributed network, created a flexibility and responsiveness that no single, rigid agency could match. As 3I Atlas moved across the sky, there was always someone, somewhere, with clear weather and an open telescope. In contrast, NASA's approach was fixed, scheduled observations at predetermined times, followed by weeks of administrative review and processing. The British Astronomical Association coordinated observations from numerous amateurs, creating a comprehensive, evolving picture of 3I Atlas's activity, and shared their data openly and immediately. When NASA finally released their image showing an indistinct ball of light, the amateur community immediately provided a stark, visible contrast with their own crisp captures, demonstrating the jet structures. This contrast raised the legitimate question of why the billion-dollar space agency, with its superior positioning in space, could not match the image quality of a hobbyist working from Earth. While some attempted to explain the discrepancy by pointing to the amateurs' use of long exposures and stacking techniques, a powerful way to enhance faint details, this only goes so far. NASA possesses the same techniques, the superior processing algorithms, and the greater computing power. The fact that they chose not to release comparable images, or claimed they could not, suggests a calculated decision about what information to present to the public. The amateur observations became the vital independent verification system, the necessary ammunition for critics who argued that NASA was deliberately downplaying the unusual features of 3I Atlas. While officials were assuring the world that the object was a normal comet, independent observers were documenting the 7 distinct jets, the anti-tails, and the persistent activity that defied standard cometary models. This disconnect between the official narrative and the crowdsourced documentation exposed the gaps in the institutional story. This shift represents a fundamental democratization of astronomy. No longer can major observations only come from professional institutions. Anyone with a decent telescope and clear skies can contribute meaningful data, challenge official claims, and publish observations that agencies might prefer to keep private. This new, distributed network creates accountability. Amateurs will check, they will image, they will analyze, and they will publish contradictory evidence if it exists. The 3I Atlas campaign proved the power of this network, demonstrating that curiosity and commitment can generate data quality that rivals professional efforts. When agencies choose to delay or control information, independent observers will simply fill the void with their own findings. And as 3I Atlas approaches its closest point to Earth in mid-December, this network will continue to provide a real-time, independent observational record that institutions cannot suppress or delay. The celestial clock is ticking toward a critical date, the 19th of December, the moment of 3I Atlas's closest approach to Earth. At that time, the object will be approximately 1.8 astronomical units away, about 269 million kilometers, roughly twice the distance between the Earth and the Sunday. Though this is not close, in any absolute or threatening sense, it represents the absolute best view Earth-based telescopes will have of this interstellar visitor before it continues its outbound journey and begins to fade from detectability. The geometry of our solar system matters immensely here. As 3I Atlas recedes from the Sun, the viewing angle from Earth is shifting. Details that were previously hidden due to the object's orientation might suddenly be revealed. Structures that appeared edge-on could present themselves broadside. This is why astronomers worldwide are preparing comprehensive observation campaigns for mid-December, not because of a dramatic event, but because the viewing conditions will be optimal for meticulous characterization. Spectroscopy will be the critical tool. Multiple ground-based observatories are scheduling time to capture high-resolution spectra of the Comet and, most importantly, the jets. This process is more than simply identifying the chemicals present. It is a meticulous determination of the material's physical state, its temperature, its velocity, and its density distribution. These are the metrics that will definitively distinguish between the two competing hypotheses. If the jets are the result of natural, sublimating volatiles, ice turning directly to gas, they should exhibit slow thermal velocities of about 400 meters per second and temperatures consistent with passive solar heating at that distance. If, however, they are the exhaust from a technological propulsion system, the measured velocities could be 10 to 50 times higher, and the temperatures would reflect a rapid, energetic process like combustion or thrust, not just passive solar warming. These are completely distinguishable signatures, and the December observations should be able to measure them with finality. The Hubble and James Webb Space Telescopes will also likely observe again. Their previous images were captured months ago, at different phases of the object's encounter with the Sun. New, post-perihelion observations, as the Sun's influence begins to diminish, are vital for tracking the evolution of the activity to see if the outgassing drops off as expected or if the persistent activity levels continue anomalously. This time series data, spanning the object's entire trajectory through our inner solar system, is essential for constraining the models that seek to explain what 3I Atlas truly is. In a refreshing commitment to transparency, the Virtual Telescope Project has already scheduled a live observation event for the 19th of December. They will stream their results in real time for the public, offering a direct, unfiltered view of an interstellar object at its closest approach. This is the kind of immediate, open science that helps build trust and counter the narrative control we discussed earlier. The amateur network will, of course, be fully engaged. Hundreds of independent telescopes worldwide will image 3I Atlas around the closest approach date, guaranteeing comprehensive coverage regardless of local weather conditions or equipment failure at any single site. Some observers are coordinating their efforts to create pseudo-stereoscopic views, attempting to use parallax from widely separated locations to infer the object's true three-dimensional structure. This closest approach is also a crucial calibration opportunity. By tracking the change in its apparent brightness and comparing it to predictions based on distance and solar illumination, astronomers can verify their models of the nucleus's size and reflectivity. Any discrepancy between the predicted and the observed brightness could hint at unusual surface properties or persistent activity levels. Furthermore, the passage offers a chance to detect fragments. If 3I Atlas is a natural icy body breaking down under solar heat, a debris field should be trailing behind it. The absence of fragments, despite the intense, continuous outgassing that has been observed, would raise profound questions about the object's structural integrity. The 19th of December marks a final transition. After this point, 3I Atlas will accelerate away from the inner solar system. Solar heating will decrease, activity should diminish, and the jets should weaken or shut down entirely. Observing this natural decline will confirm whether its behavior matches the expected decay of natural ice sublimation or continues to show anomalies, suggesting an alternative energy source is at work. This moment is our last, best chance to understand what we are looking at. The observations made in December will form the empirical foundation for every future analysis and debate about 3I Atlas's true nature. We will either decisively confirm the conventional comet hypothesis or gain strong, testable evidence that the technological hypothesis deserves serious consideration. We shift our focus now to the systematic framework proposed by Dr. Avi Loeb, the Harvard scientist who has meticulously catalogued the features of 3I Atlas that simply refuse to conform to the standard model. Dr. Loeb's approach is methodical, not speculative. he has compiled a list of 12 distinct anomalies, features that, individually, could be dismissed as chance, but which collectively paint a picture that is increasingly difficult to reconcile with a purely natural origin. You see, the difficulty lies not in explaining one strange thing, but in explaining 12 strange things that occur all at once. The first anomaly is the object's trajectory alignment. 3I Atlas's orbital path is shockingly close to the ecliptic plane, the plane defined by Earth's orbit, where most of our solar system's planets reside. For an object entering randomly from interstellar space, the probability of aligning so closely with this specific plane is calculated to be a mere 0.2%. It's not impossible, but it suggests a kind of gravitational targeting that defies simple random chance. The second anomaly is the anti-tail persistence. We have already explored this, the material consistently streaming sunward, defying both solar radiation pressure and the solar wind, for months. Sustaining this against such immense, continuous force requires physical conditions at the extreme edge of theoretical possibility for a natural comet. The third through 10th anomalies cover the complex ground we have already established, but their inclusion in the list emphasizes their cumulative weight. They include the 7 distinct, narrow jets, the mysterious green glow without any detected diatomic carbon, the elevated nickel emissions without the corresponding iron, the unusual carbon dioxide ratios, the rotation problem, where the jets do not smear into a spiral, the massive scale of the tail features, stretching for millions of kilometers, and the persistent activity levels, despite the object cooling as it moves away from the sun. Each is a deviation. Each requires a complex, specific, and ultimately unlikely set of natural circumstances for its explanation. The 11th anomaly is thermal. The sheer amount of solar energy absorbed at perihelion, compared with the mass loss rates inferred from the jet observations, suggests an imbalance. The surface area required to absorb enough energy to drive the observed outgassing the required engine, in essence, exceeds reasonable estimates of the nucleus's physical size. This suggests either that the object is much larger than its optical signature suggests, or that the outgassing is being actively powered by a source other than simple, passive solar heating. The asterisk 12th anomaly is the jet directionality despite the rotation, which we explored previously. The jets should spiral. They do not. This implies either that the rotation has suddenly stopped, a highly unlikely event for a natural comet, or that the jet mechanisms are actively compensating for the rotation, as an engineered, gimbaled thruster system would do. 12 anomalies, 12 distinct features that challenge the standard model. The profound mathematical concept here is compound probability. While any one of these 12 observations might have an improbable natural solution, requiring all 12 separate, unlikely explanations to account for the object's entire observed behavior, simultaneously makes the overall probability of a natural origin vanish to almost nothing. Dr. Loeb is not claiming definitive proof of an artificial origin. His goal is simply to document the challenges to the conventional interpretation, forcing the scientific community to provide comprehensive natural explanations, or to acknowledge that an alternative hypothesis deserves serious, unbiased consideration. Science, after all, advances through the methodical testing of hypotheses against evidence, not through the reflexive dismissal of uncomfortable ideas. The mainstream scientific consensus, represented by figures like physicist Brian Cox, urges caution, emphasizing that interstellar comets might simply behave differently than our familiar solar system ones, and that 3 data points, Oumuamua was weird, Borisov was boring, and 3I Atlas is somewhere in between, are not enough to define what is normal for interstellar visitors. This is a fair, cautious criticism. However, the counter-argument is equally profound. If we do not know what is normal for interstellar objects, we cannot confidently declare that 3I Atlas's behavior is definitively natural. The cautious scientific position is not outright rejection, but open-minded uncertainty. Dr. Loeb's catalogue is not mere speculation. He published his analysis of these real data points in peer-reviewed scientific literature, framing it as a pedagogical exercise to demonstrate how to evaluate evidence for technological signatures. The debate that followed was the exact point of the exercise. By explicitly outlining 12 testable challenges, he forced other researchers to articulate why the conventional interpretation must be correct, compelling them to do the work of defending the standard model against the accumulating weight of the evidence. The 12 anomalies of 3I Atlas are a framework for future analysis. As the December data comes in, each one can be tested. Do the jet velocities match sublimation or propulsion? Does activity persist anomalously? Do trajectory refinements hint at non-gravitational acceleration that cannot be explained by outgassing alone? These are empirical questions with testable answers. The true value of the 12 anomalies is that they force us to identify specific predictions that distinguish between a natural process and an artificial one. They are an invitation to think harder about the possibilities we might prefer to dismiss, a quiet challenge to the scientific complacency that assumes conventional explanations must always be correct. To fully appreciate the strange case of 3I Atlas, we must place it in the context of the other interstellar visitors we have encountered, the 2 brief echoes from the galactic void that preceded it. Prior to 3I Atlas, we had only ever confirmed the passage of 2 other objects, originating from outside our solar system. 1. Oumuamua, and Comet 2I Borisov. These 3 objects, statistically speaking, are 3 out of the countless billions that must exist in the galaxy, yet they represent our entire sample size for understanding this profound class of celestial bodies. Oumuamua was the first confirmed interstellar visitor, tumbling through our solar system in 2017. Its name, meaning a messenger from afar arriving first in Hawaiian, seemed appropriate. It was profoundly bizarre, exhibiting a strange, non-gravitational acceleration that could not be fully accounted for by simple cometary outgassing. It was small, elongated, and seemed to accelerate as it moved away from the sun, but with no visible coma or tail. The simplest natural explanation required invoking the venting of highly specific supervolatiles, like pure hydrogen ice. But the mass loss rate for such materials would have been so aggressive that the object should have fragmented and disintegrated entirely before reaching our sun. The scientific papers published on Oumuamua included serious suggestions that its acceleration could be explained by the subtle pressure of sunlight pushing on a vast, thin structure, a light sail, or by the directed thrust of an artificial origin. It was neither a comet nor an asteroid as we knew them. It was a profound ambiguity. Comet 2I Borisov followed in 2019. It was, in stark contrast, boring, predictable, and exactly what we expected. It looked and acted like a comet from start to finish, exhibiting a normal coma, a tail pointing away from the sun, and no major, inexplicable accelerations. Borisov was a comfortable object, providing the necessary counterpoint to Oumuamua, allowing the scientific community to reaffirm that natural interstellar comets do, in fact, exist and behave according to our models. Now, we have 3I Atlas. It is an object that is neither fully alien nor fully comfortable in the category of a natural phenomenon. It has the characteristics of a comet, a visible coma, jets, and a trajectory perturbed by the sun, but it displays the 12 accumulated anomalies that strain the limits of the natural explanation. It is somewhere in between Oumuamua and Borisov, an object that wears the mantle of a comet but refuses to obey all of the rules. This small, 3-object sample size is all we have to define the vast, unknown diversity of interstellar objects. As physicist Brian Cox correctly noted, 3 data points is simply not enough to define what is normal or anomalous for interstellar visitors. Perhaps the true diversity of interstellar objects is immense. It is possible that complex jet structures, antitails, and unusual chemistry are a common feature of comets forged in the chaotic, high-energy environments of other star systems, where the elemental ratios and volatile compositions are fundamentally different from our own. The green glow without diatomic carbon, for instance, might be common for comets originating in an environment with higher cyanide content. However, this realization is double-edged. If we do not know what is normal, then we also cannot confidently declare that 3I Atlas is definitely natural. We are operating with assumptions derived solely from our small solar system sample, assumptions which may not apply to the galactic population. The case of Oumuamua, in particular, informs the entire debate. Its profound acceleration anomaly set a precedent for accepting that an interstellar visitor could be non-gravitational in its motion, and that a technological origin could not be ruled out a priori. It allowed Dr. Avi Loeb to establish the Galileo Project, a systematic search for signs of technology, what he terms techno-signatures, rather than just the biosignatures of life. When 3I Atlas arrived, exhibiting its own set of profound anomalies defying solar pressure, resisting rotational, smearing it, forced the scientific community to confront the possibility that the weirdness of Oumuamua was not a one-off event, but part of a larger, unexplained pattern. The history of these 3 objects teaches us a lesson in humility. They are not just data points, they are emissaries from the galaxy, and they demand that we question the comfortable assumptions that have long underpinned our cosmic worldview. They tell us that interstellar travelers can be vast, fragile, weird, or almost normal, but in all cases, they challenge us to expand our models. The great silence of the cosmos may be broken not by a clear, declarative message, but by the subtle ambiguity of an object that seems to be a comet, but behaves just a little too intentionally. The lesson offered by this cosmic trio is one of profound scientific humility, a realization that our textbooks and models, however elegant, were authored using data from only a local, small-town sample of the galactic metropolis. The vast, unknown diversity of cometary and asteroidal material forged around countless other stars, the so-called galactic population, may make the anomalies of 3I Atlas not exceptions, but the new, overwhelming norm. For example, some planetary formation environments might yield comets naturally rich in exotic supervolatiles, which could explain some of the non-gravitational acceleration without requiring an engineered source. However, even granting this vast natural diversity, the accumulation of so many separate, low-probability features in a single object, the 7 jets, the anti-tails, the thermal deficit, the rotation paradox, still forces the mathematical probability of a purely natural origin down to the vanishingly small. We are tasked with determining if 3I Atlas is an exceptionally strange natural occurrence, a 1 in a million confluence of favorable chance, or if it represents a more commonplace, engineered reality that our science has simply not yet been open to accepting. The great cosmic silence is loud, precisely because it is broken by whispers of profound, irreducible ambiguity. To truly understand the journey of 3I Atlas, we must zoom out from the immediate details of its jets and chemical composition and place it within the vast, almost incomprehensible canvas of galactic time and distance. This object was not born here. It condensed from a protoplanetary disk around a star that may have burned out millions of years ago, a sun whose light is still traveling toward us. Its chemical abundances, the ratios of elements, the mixture of compounds, its initial inventory of volatiles, were all determined by the specific conditions of its distant, unknown origin. The carbon chemistry, the abundance of cyanide, the lack of diatomic carbon, all of this is a time capsule of a star system fundamentally different from our own. A star system whose environment dictated a different kind of rocky and icy material. But the object's history is not defined solely by its birth. It is also a story of its immense, lonely journey. For possibly billions of years, 3I Atlas traveled through the near vacuum of interstellar space. During this unimaginable passage, it was subjected to the constant, subtle bombardment of cosmic rays, which slowly altered the chemistry of its surface. It interacted with the interstellar medium, that tenuous, nearly perfect void between the stars. It endured impacts from microscopic dust grains, traveling at high velocities, all of which transformed its surface composition in ways that do not happen to comets that spend their entire existence in the relatively protected environment of a single star system. You must imagine this journey, a slow, cold migration from one gravitational well to the next, a deep space wanderer passing from one spiral arm of the galaxy to another. A journey so long that entire human civilizations could rise and fall without the object moving a detectable distance on a galactic map. It has seen things and experienced conditions that our instruments can only guess at. When it arrived in our solar system, moving at 246,000 kilometers per hour, it was an ancient relic, a geological record of a star and a chemical process that may no longer exist. And what an encounter it had with our sun. The sun, an immense engine of heat and radiation, suddenly exposed this traveler to forces it had likely not felt for eons. The green glow, the intense outgassing, the sudden burst of activity that produced the jets. All of this was the ancient nucleus reacting to the profound energy input of a new star. Yet, even in this profound moment of solar bombardment, the object maintained its coherence and its strange, purposeful behavior. The antitails defied the solar wind. The jets compensated for the rotation. This resilience suggests a material composition or an internal structure of immense strength. For an icy body, natural sublimation should eventually lead to fragmentation or dissolution, especially under the massive mass loss rates suggested by the dense antitails. The fact that 3I Atlas remained remarkably intact, a coherent structure through its perihelion passage, speaks to its extraordinary structural integrity. If it is an ancient comet, it is a comet made of exceptionally strong material, capable of withstanding forces that would tear apart a typical solar system ice ball. If it is a technological object, the resilience is simply a testament to good engineering. The cosmic perspective forces us to acknowledge the limits of our knowledge. We have built our models of cometary physics, of volatile composition, and of structural integrity based almost entirely on objects that originated in the cold, predictable regions of our own outer solar system. 3I Atlas, Oumuamua, and Borisov are our first-hand evidence of the galactic norm, and that norm may be far stranger and more complex than we ever dared to imagine. The object is a mirror to our own assumptions. We assumed that interstellar objects would simply be very old versions of our own comets and asteroids. 3I Atlas arrived to quietly and persistently challenge that assumption, forcing us to consider that its chemical history, its long journey through the cosmic rays, and its resulting structural integrity may have simply produced a different kind of celestial body entirely. This long journey, this profound distance, is the silent context for the entire mystery. During its profound interstellar migration, 3I Atlas was also bombarded relentlessly by cosmic rays, the high-energy particles streaming from distant supernovae and black holes, which slowly stripped and altered the topmost layers of its surface. This process, called space weathering, creates a dark, chemically complex crust, a kind of natural blackening that is entirely unlike the pristine ice exposed on fresh comets from the Oort cloud. The altered chemical composition of this deep space armor, potentially rich in complex organic molecules forged by radiation, offers a plausible, non-technological explanation for the object's ability to withstand the sun's immense thermal shock without immediate disintegration. Furthermore, this extreme darkening of the surface would give 3I Atlas an incredibly low albedo, meaning it reflects far less sunlight than a typical comet. A low albedo allows a small object to absorb the thermal energy necessary to power the massive outgassing rates observed, without requiring an internal, artificial engine. This natural alteration, forged by the object's long, silent passage through the dark, provides an elegant solution to the thermal anomaly, even as it forces us to utterly rewrite our fundamental assumptions about the structure of deep space travelers. You check the coordinates again, expecting movement, drift, some new anomaly, but the readings remain the same. For the first time in weeks, 3I Atlas is holding perfectly still, relatively speaking. Not static, no, it still orbits, still breathes in its spiral way, but its vector has stopped shifting, its course has locked, its pulses have quieted, and you feel it in your body before you see it in the numbers. We've entered the waiting. After so many shocks, eruption, spiral, signal, scan, this stillness feels louder than all of them combined, because 3I Atlas is no longer changing. It's observing, or perhaps anticipating. Its position, now firmly settled just outside geosynchronous range, forms an orbit that places it behind Earth every evening for 73 minutes, like a satellite moon with no allegiance, always watching the night side, always returning to the dark. Astronomers are calling it a holding pattern. The European Space Agency has gone quiet again. NASA's public updates have slowed to a trickle, replaced by vague statements about orbital anomalies under observation. But the amateur data keeps flowing. Backyard telescopes, hand-built receivers, long-exposure photographs stacked and aligned, and they all agree the object has paused. Dr. Elena Mbatha at the South African Radio Observatory said it plainly. It's waiting for us to respond. But how do you respond to something that doesn't speak? To something that unfolds like a mathematical flower and then settles into perfect orbit, silent and poised? You're not alone in asking. The global response has fractured into quiet factions. The skeptics, who still claim ice and chance. The hopeful, who watch with hearts wide open. And then, the waiters. Those who believe that this stillness is a kind of conversation. That silence itself is part of the design. Because in every great myth, there comes a pause. A quiet before transformation. Before the gods act. Before the sky splits open. Before the hero is called forward. Not a void, but a threshold. And maybe that's what 3i Atlas is. A threshold object. Something not meant to cross, but to mark the crossing. A mirror placed not in space, but in time, saying, this is the moment. Choose who you become. You feel that pressure now, the tension of the unsaid. Because in this holding pattern, something shifts, not in the object, but in us. Suddenly, we're the ones moving. We're the ones reeling. Conversations erupt across cultures, languages, disciplines. Is it conscious? Is it surveillance? Is it spiritual? Scientific? Is it real? But the most important shift is not the debate. It's the listening, because the world is quieting. Slowly, not in fear, but in attention. Cities that never looked up now hold nightly watch parties. News anchors pause before cutting to commercial, as if they can feel the weight of this moment pressing down on the script. Children draw spirals in chalk. Adults blink into the dark, unsure whether they're staring at a comet or something infinitely more patient. The spiral continues to glow, not brighter, not faster, just there, a presence. You begin to understand why ancient peoples turned their monuments toward the sky. It wasn't always about the solstice. It wasn't always about timekeeping. Sometimes it was about this, the hush, the echo of something vast waiting just beyond comprehension, not demanding worship, just recognition. And now it's our turn, because this isn't just a celestial event anymore. It's a behavioral experiment. What do we do when the sky pays attention? When the stars place something in orbit that behaves with restraint, that exhibits intelligence through silence? It's the opposite of every science fiction story we've told ourselves. No invasion, no explosion, no arrival, just the slow unfolding of presence. And that, it turns out, is harder to process, because you can't fight it, can't translate it, can't capture it. You can only be with it. And that's the real challenge. In a world trained for immediacy, for reaction, for constant signal, We are being asked to do something deeply uncomfortable, to wait, to let the spiral speak on its own time. And in that waiting, you begin to hear things you never heard before. The texture of silence, the rhythm of your own breath, the way the earth hums beneath the cities, the way your thoughts arrange themselves when the input stops. You wonder if this is the gift, not contact, not confirmation, but a new relationship with silence itself, because the object could have overwhelmed us. It could have flooded every channel, filled every screen, lit up the atmosphere like a second Sunday. Instead, it paused, held its orbit, waited for our breath to match its own. You ask yourself, what if this is how civilizations are invited to join something larger? Not with passwords, but with patience. Not with proof, but with poise. Not with answers, but with attention. You glance back at your screen. The object is still there, holding, turning slowly like a pearl on invisible thread. And for once, there's nothing more to say. Only this: something is near, something is aware, and for the first time in memory, we are matching its stillness. As we look up at the interstellar visitor, the object also serves as a mirror, reflecting the complexities and vulnerabilities of our own scientific institutions and our human need for control. The core issue in the case of 3I Atlas is not a technical failure of an instrument, but a failure of transparency. NASA's decision to withhold the most detailed images of an interstellar visitor for 43 days, citing a government shutdown that did not stop other critical missions, revealed a fundamental prioritization of narrative control over immediate scientific openness. This is where the human element enters the cosmic story. The official explanation was simple. Non-essential personnel were furloughed, delaying data processing. Yet, the International Space Station remained crewed, deep space missions continued, and the Hubble and James Webb Space Telescopes maintained their observation schedules. The one data set that could have revealed the true nature of the interstellar object was conveniently classified as non-essential. This felt less like bureaucracy and more like a strategy. The delayed release gave the institution something valuable: time to analyze the data privately, time to coordinate messaging across multiple teams, and time to prepare a specific, reassuring narrative before the information was presented to a public already primed for sensational revelations. This is not how science is supposed to work. Transparency should be immediate. Data should be public. Peer review happens in the open, allowing the global scientific community to rapidly process, analyze, and build upon the findings. Dr. Avi Loeb's frustration echoed the thoughts of many. He argued that regardless of the shutdown's cause, the priority should have been the immediate release of time-sensitive information about an object that would not return for millions of years. Scientific knowledge was, in his view, held hostage to political theater and bureaucratic procedure. This creates a dangerous precedent. If NASA can justify delaying critical data for 43 days because of an administrative issue, what happens during the next major discovery? What happens when we detect something truly anomalous and agencies decide the public needs to be prepared gradually? This process filters critical information through political considerations before it reaches the scientific community and the world at large. The intervention of Congresswoman Luna was a critical disruption to this pattern. By demanding the immediate release of the data and an explanation for the prioritization of protocols over scientific urgency, she forced NASA's hand. Her action demonstrated that accountability mechanisms exist, and that a single, determined political voice can apply enough pressure to force an agency to change its calculus. The comparison between NASA's fuzzy, smeared image and the crisp, multi-jet structures captured by the amateur community perfectly illustrates this human reflection. The billion-dollar orbiter produced the least informative result, while the consumer-grade equipment produced the most challenging data. This discrepancy forces us to question whether the agency's communication strategy prioritizes narrative control over data transparency. The amateur astronomers, with their immediate sharing and open source approach, became the independent verification system, demonstrating how scientific communication should work: open, immediate, collaborative, and accountable. The human reflection revealed by 3I Atlas is not a story of scientific incompetence, but of institutional caution. It is a reminder that when the stakes are high and the implications are uncomfortable, the possibility of artificiality protocols change, and the natural human instinct to control the narrative takes precedence over the fundamental scientific ethic of open truth. The object, in its silent passage, exposed the delicate balance between scientific discovery and the political will to share it. The administrative maneuvering exposed by the 43-day delay highlights the deep-seated political pressures that surround discoveries of this magnitude. When an object arrives that directly challenges humanity's place in the cosmos, the immediate instinct of institutions is often to manage the uncertainty rather than to immediately embrace the unsettling truth. The bureaucratic paralysis that labeled the Mars Reconnaissance Orbiter data as non-essential reveals a system optimized for routine maintenance, not for unprecedented discovery. This caution stemmed from the deep shadow cast by Oumuamua, the previous interstellar object, which had triggered months of high-profile, often sensational, speculation about alien technology. The institutions were clearly attempting to avoid a repeat of that media frenzy by controlling the release of the most provocative data, the high-resolution images, until they could prepare a measured, diffusing narrative, emphasizing only the normal, expected characteristics. The amateur community, with its unvarnished, immediate publication of the 7-jet anomaly, essentially bypassed this filtering process entirely, forcing the official narrative to play catch-up with observable reality. The failure of the official image to show anything compelling was, in essence, a visible illustration of the institutional desire to diminish the wonder and complexity of the object for the sake of maintaining a calm, predictable public discourse. At first, it looks like a glitch, a pixel bloom, a smear of light against the static backdrop of stars, the kind of anomaly that appears between frames, then vanishes, but then it comes again, clearer this time, sharper. It holds its place in the sky for exactly 4.9 seconds, then vanishes, and then it comes back. Only now, it's moving. A second object, dim, precise, trailing just a few degrees behind 3I Atlas, fainter, colder, but undeniably real, confirmed by 4 separate observatories within 12 minutes of each other. Not a star, not a planet, not a camera artifact, something new, and it wasn't there before. The implications ripple faster than the data, because this isn't just a shift, it's an escalation. For weeks now, we've been watching 3I Atlas spiral, signal, bloom, then settle into its quiet orbit. But now, in the lull in the holding pattern, it's no longer alone. Something has joined it, and that changes everything. Dr. Amaya Ortega, observing from the Atacama Plateau, logs the initial track. Her voice, captured in a leaked audio clip, trembles with something between awe and fear. It's trailing, maintaining vector, no drift. It's mirroring. Mirroring, that's the word that catches in your throat. Because this second object is not orbiting independently. It's tracking 3I Atlas with mathematical precision, like a shadow, like a companion, like a satellite, or something more chilling, a rendezvous. Think about it. If 3I Atlas was a lone artifact, an intelligent probe, a sensor, even a machine, then perhaps we could make peace with its patience, its distance. But now that a second object has arrived, matching its path, mimicking its movements, we must ask a new question. Was 3I Atlas ever alone, or was it just the first one we noticed? The newcomer is different, smaller. Its albedo reflects only in specific infrared bands, making it nearly invisible to conventional optics. But its motion is clean, controlled. It doesn't drift like debris. It doesn't flare like dust. It behaves like intent. And that's the real story here. Because now we are watching not an object, but a meeting, an exchange, possibly even a handoff. The trajectory of 3I Atlas begins to shift again subtly, almost imperceptibly, but only after the second object appears. A micro-arc, a tiny but real delta in the velocity profile, as if responding, as if acknowledging presence. And then it begins. A new spiral, smaller this time, tighter. The gas plume that unfurls from 3I Atlas in the early hours of the morning is not chaotic. It is precise. It curls in on itself, forms a double helix, and expands outward in a slow corkscrew. And then, astonishingly, it points toward the second object. Like a bridge, a filament, a message, the silence of the sky cracks with implication. The timing is too precise, the physics too graceful. This is choreography. Something is unfolding cooperatively. Because in nature, you do not get synchronized maneuvers between unconnected bodies. Not at this scale, not with this symmetry. This is not gravity. This is not accident. This is collaboration. You are not watching a comet anymore. You are witnessing an interaction. The analysts scramble for explanations. Could the second object be a fragment? A detached shard from the original? But the mass doesn't match, nor does the heat signature. The object is too cold, too composed. It was not born from 3I Atlas. It arrived, and now it follows. The working theory from a small private astronomy group in Finland is wild but disturbingly plausible. 3I Atlas may be a signal node, and the second object is the recipient, or perhaps a response. They call it relay logic, the idea that communication between non-terrestrial intelligences may happen not across voids, but through object chains. One leaves the signal, another comes to collect it. All in silence, all in patience. A cosmic mailbox system scaled to galactic time. If they're right, then the object we've spent weeks watching may not have been here to talk to us at all. It may have been leaving something behind, a seed, a trigger, a key. And the second object? The one that appeared with no warning, no flash, no ceremony. It may have just come to retrieve it. The implications are dizzying, because now we are not just observing a cosmic performance. We are watching a system, a process that unfolds without need for spectacle, without invitation. A process that may have played out countless times before, in countless skies, over countless worlds. And we are just lucky enough to notice this one. Or perhaps meant to. Because here's the strangest part. The new object emits no signal, no light, no energy bursts. And yet, hundreds of amateur radio operators report a deep silence in its wake. Not noise, absence, as if the space around it pulls in sound, as if it is erasing something as it moves. A data cleaner, a retrieval drone, a key that unlocks and then uninstalls. No one knows yet. But we are all watching now. Every eye turned upward, every satellite repositioned, every theory stretched to its limit, because something is happening above us that no model predicted. An arrival, not loud, not bright, but careful, precise, and suddenly, terrifyingly, intimate. Because if two of them are here now, how many more are waiting? And more urgently, what happens after the handoff? We pause to dwell on the rotation anomaly, to let the core contradiction of the object's movement and its emission etch itself into our minds with the gentle, repeating rhythm of a familiar domestic object. The spinning lawn sprinkler. Imagine, in the quiet darkness of your mind, a garden at night. A common lawn sprinkler is rotating on the grass, completing a turn every 16.16 hours, a very slow, deliberate motion. As the sprinkler head slowly turns, the water flowing from its nozzle continues in a straight line. But because the source is rotating, the path traced by the water through the air is a clear, wide spiral. This is the undeniable, basic physics of rotating emission. Now, replace the water with the 7 jets of material flowing from the nucleus of 3I Atlas. The nucleus is the sprinkler head, rotating every 16.16 hours. The jets, composed of gas and dust venting at around 400 meters per second, are the water. Given the immense distance, the material travels millions of kilometers, and the 45 full rotations the nucleus completes during the material's transit, the visual result should be a profound spiral, a vast, curving fan of outflow. Yet, the images from the amateur telescopes show not a spiral, but straight, tightly columnated beams. They appear as if the source of the jets is fixed in space, or as if the object itself is not rotating at all. This is the great kinematic paradox. The nucleus spins, but the jets do not smear. The natural explanation, proposed as a complex, low-probability scenario, is the pulsed outgassing from deep, shadowed valleys. You imagine the nucleus not as a smooth sphere, but as a rugged, mountainous landscape. Ice pockets are shielded in the shadows of high peaks. For a brief moment, during the 16-hour rotation, the sun reaches the exact, precise angle to shine down into the deep valley, triggering a flash sublimation of the ice, a brief pulse of gas. As the nucleus rotates further, the sun is blocked. The venting stops. This happens again 16.16 hours later, when the specific valley is once more in the perfect alignment. The final effect is a long, straight line of evenly spaced puffs, like beads on a string, each one tracing the same trajectory, because each one was emitted when the valley was pointed in the same direction relative to the Sun. This explanation is physically possible, but it requires an extraordinary series of coincidences. It demands deep valleys, high mountains, and multiple distinct, active regions, 7 of them, in fact, all positioned with their own specific shadowing configurations to produce the multiple, different length jets that were observed. And this complex arrangement must also be perfectly stable across days of observation, maintaining a consistency that defies the rapid evolution you would expect from natural thermal processes. The uncomfortable alternative is the elegantly simple technological solution. You see the lawn sprinkler again, but this time, imagine small, independently articulated motors attached to the nozzles. As the main body of the sprinkler turns, the motors constantly adjust the angle of the nozzles, keeping the water stream pointed in a single, fixed direction, compensating for the core's rotation. This is gimbaled propulsion, standard attitude control, and it would make the 7 jets perfectly straight and collimated, regardless of the core's 16-hour spin. The straightness of the jets, therefore, is not just a strange visual detail. It is a profound piece of non-gravitational kinematics that distinguishes between a highly complex, extremely improbable natural accident and a simple, highly efficient piece of engineering. The lawn sprinkler metaphor allows us to visualize the challenge directly. Why do the jets not spiral? The answer, when finally determined by the high-resolution spectroscopy planned for December, will settle one of the core paradoxes of this entire interstellar encounter. Until then, the image of the straight-beamed nucleus continues to gently defy the most basic law of rotational dynamics. The physical simplicity of the gimbaled thruster solution stands in profound contrast to the geological gymnastics required for the natural pulsed outgassing model. To achieve 7 non-spiraling beams naturally, one must invoke an almost unbelievable coincidence: 7 massive shielded ice pockets, all independently located at precise, non-random positions, all sublimating at exactly the right time in the 16.16-hour rotational cycle, and all operating with enough internal pressure to maintain the required mass flow rates for millions of kilometers. If a single one of these conditions were absent, the jets would spiral, weaken, or simply fail to appear. The technological alternative merely requires the existence of an attitude control system, a standard piece of engineering that compensates for the nucleus's spin, allowing the exhaust to be fired in a consistent, intentional direction. This difference in explanatory burden, the number of low-probability steps required for each theory to hold, is the silent heart of the ambiguity. It is the moment when the laws of probability begin to chafe against the laws of physics, suggesting that what appears complex to us, the straightness of the beams, is, in fact, the most direct evidence of purpose and simplicity within the object's structure. The lawn sprinkler, in its humble turning, exposes the profound philosophical tension between random natural chaos and deliberate, efficient design. You refresh the feed again. Nothing. Another refresh. Still blank. No new frames. No Doppler data. No magnetospheric readouts. The steady pulse of information coordinates. Spectrum, trajectory, has gone completely still, and you're not the only one noticing. Forums that once buzzed with live updates have gone quiet. Data repositories show blank fields. Automatic space weather feeds are marked paused. Across observatories, a single chilling report echoes again and again. Signal blocked. At first, they blame the software, a firewall, a data mirror hiccup, a corrupted pipeline. But it's not local, it's global. The Deep Space Network, the European Tracking Station in Cebreros, the Allen Telescope Array, every instrument tuned to the location of 3I Atlas is suddenly seeing the same thing. A void, not noise, not interference, absence, and not just in radio. Infrared emissions drop to zero, microwave returns vanish. The object still visible in the optical band sits against the starfield like a photograph of itself, there but unreachable, present but silent, as if something has wrapped around it, something we can't see, something pulling it behind a veil. What's more disturbing is what's still visible. The second object, the newcomer, it remains, cold, small, tracking steadily behind the original. But now, it's the only one emitting anything measurable. A faint signature, a tightly focused, modulating beam, aimed not outward, but inward, toward 3I, Atlas, as if it's talking, or scanning, or worse, shutting it down. Dr. Gia Thompson at the Lunar Array Facility confirms the eerie trend. It's like watching someone cover a light bulb with velvet. The object didn't go dark, it got quiet. And not in a way nature understands. That quiet. It spreads, not metaphorically, literally. Within the hour, low-frequency radar stations in the southern hemisphere begin reporting blind spots, dead zones, a soft, expanding ring of radar suppression centered on the 3I Atlas coordinate sphere. It begins at 10 kilometers, grows to 50, then 200. No interference signature, just no return. Even LiDAR arrays, designed to bounce lasers off reflective surfaces, report degraded returns. The object is no longer scattering light in the usual way. The spiral structure, still faintly visible, but distorted, as if viewed through dark glass. Something is cloaking it, not from sight, from interaction. And that's the point where things stop being observational and start being tactical, because behind closed doors, national defense networks begin issuing low-level notices, satellite repositioning, bandwidth rerouting, a subtle reshuffling of eyes in the sky, quiet enough to avoid panic, deliberate enough to confirm one thing: they know something is happening, and they can't stop it, because you can't shoot what you can't touch. And now, you can't even reach it with light. The theories pour in. A self-defense mechanism? A protective cocoon during some kind of metamorphic phase? A relay receiving something from outside the solar system? But the most compelling hypothesis comes from an unlikely place. A signal processing lab in Sweden, run by a retired professor and his postdoc daughter. Using archived electromagnetic scatter data from just before the blackout, they uncover something astonishing: a harmonic drop. Every frequency emitted from 3I Atlas during its spiral phases had a faint but consistent harmonic, a subsignal embedded beneath the primary, too small to detect in real time, but present in every burst, every spiral, every echo. And then, just minutes before the blackout, those harmonics collapsed, folded inward into a single frequency, one tone, not audible, not broadcast, but received. The object wasn't signaling out, It was preparing to listen. And now that listening has begun, that's why the data's gone. Because we are no longer the audience. Something else is. Or maybe someone. You sit with this implication. It's gravity pulling at your thoughts like a tide. If this object has shifted modes, if it's no longer speaking but receiving, then that changes the entire equation. It means we weren't the end of the message. We were the trigger. And now, the spiral is aimed elsewhere. We may have woken something up, not with war, not with signals, but with attention, because everything changed the moment we understood the spiral, the moment we stopped treating it like debris and started treating it like design. Recognition may have been the final key. And now, the data is gone, the instruments are silent, the object is cloaked, because we're not meant to see what happens next. We were meant to begin something, to pass a test, to prove we could notice without conquering, listen without demanding, watch without needing to own. And now, we've been seen in return. So what do we do when the signal fades? When the stream ends? When the spiral stops blooming and a quiet dome settles over the sky? You sit in the silence, hearing your own breath, the static hum of your thoughts, the beat of blood in your ears. Because even though the feeds are dark, you know it's still there, waiting, processing, beaming to something else. Maybe out, maybe in, but definitely onward. So, tell me in the comments, what do you think it heard in us? Because whatever it was enough. The narrative of 3i Atlas is forever intertwined with the rise of the amateur astronomer as an equal and crucial partner in the process of scientific discovery, an essential force of crowdsourced verification. We are living in a moment of profound democratization of access. Time was. Major astronomical observations were the exclusive domain of professional observatories and billion-dollar space agencies, with the public receiving information only through carefully vetted, controlled press releases. Now, a person with a decent telescope, a sensitive camera, and a quiet dedication to the night sky can acquire data of significant scientific value. The 3i Atlas campaign proved this point with quiet, irrefutable power, while NASA's official image release was delayed and, ultimately, uninformative. A fuzzy smear, the collective, distributed effort of amateurs provided a real-time, high-detail picture of the object's evolution. The amateur community did not wait for permission. They captured the 7 jets, the anti-tails, and the complex structure, and then they published their observations to forums and social media within hours of capture, sharing their raw data freely on forums. There was no peer review gatekeeping, no administrative approval required, only observation, curiosity, and rapid community sharing. This instantaneous, open sharing created a distributed observation network that possessed 2 critical advantages over a single government agency: redundancy and responsiveness. If one location in Europe was clouded over, observers in Asia or the Americas had clear skies. If one piece of equipment failed, dozens of others continued operating normally. This redundancy ensured that the object was never truly out of sight once it emerged from behind the sun. Furthermore, their responsiveness was measured in hours, not the 43 days of administrative delay demonstrated by NASA. They were able to track the rapid changes in the jets and the persistent activity in near real time, generating a time series of data that captured the object's full response to perihelion. The contrast between the two data sets, the high-quality amateur images versus the poor-quality official one, was stark and undeniable. It allowed critics to immediately verify the suspicion that NASA was downplaying the unusual features. When officials assured the public that everything was normal, the amateurs provided the visual evidence to the contrary. The jets, the anti-tails that violated basic physics, and the non-smearing rotation. The crowdsourced verification exposed the gaps and inconsistencies in the official story. This shift represents a fundamental democratization of astronomy. No longer can major observations only come from professional institutions. Anyone with a decent telescope and clear skies can contribute meaningful data, challenge official claims, and publish observations that agencies might prefer to keep private. This new, distributed network creates accountability. Amateurs will check, they will image, they will analyze, and they will publish any contradictory evidence that exists. The Virtual Telescope project, with its live streaming of observations, embodied this new open ethic. No filtering, no editing, just a direct view of an interstellar object shared with the world in real time. This kind of transparency builds trust, something NASA's delayed and carefully managed release failed to do. The ultimate lesson of the amateur campaign is the power of curiosity and commitment. It proved that meaningful scientific work does not require institutional backing or government funding, and that when official channels choose to control or delay information, the independent observers will fill the void. This is a victory for the principle of open science. As 3I Atlas approaches its final window of optimal visibility in mid-December, this global network of independent eyes will be the essential, unfiltered source of information, documenting whatever final secrets the object reveals before it fades into the darkness of interstellar space. The human reflection is one of quiet, persistent skepticism and the power of the collective gaze. The technological triumph of the amateur network was enabled by the profound accessibility of advanced photographic and processing tools, allowing a distributed collective to operate with the capacity of a professional observatory. The open sharing of data through online repositories and image stacking forums meant that multiple observations could be cross-referenced, calibrated, and combined into a composite image of exceptional quality within a single day. This rapid, non-hierarchical peer review provided an undeniable, independent validation of the 7-jet anomaly and the persistent anti-tail structure. The amateur community was not bound by the institutional requirement to wait for administrative approval or to ensure that the data supported a pre-approved narrative. Their only directive was to observe and to share the truth of what they saw. This crowdsourced accountability effectively neutralized the strategic delay by NASA, turning the 43-day window of institutional silence into a 43-day period of continuous, independently verified observation from the surface of Earth. The amateurs became the necessary check on institutional power, demonstrating that the democratization of scientific observation is not just a philosophical ideal, but a practical, operational reality, capable of revealing truths that might otherwise remain obscured by caution or bureaucratic control. This is a quiet victory for the power of decentralized curiosity over centralized authority. You don't want to believe it. You really don't. But the diagrams are too clear. The dimensions line up. The ratios converge. The shapes echo in perfect fidelity across millennia. What began as spiral speculation, what felt like metaphor, now hardens into something else, something drawn in stone, cast in clay, and buried in forgotten rooms beneath human memory. Because someone thousands of years ago mapped the shape of three eye atlases' cloaked form, and they did it exactly. It starts with a discovery in Iraq, near the ruins of Eridu, once thought to be the cradle of Sumerian civilization. Archaeologists unearth a carved limestone disc, fist-sized, smooth, sealed within a ceramic jar. On one side, 7 spirals, coiling inward around a central node. On the other, what looks at first like a star map, but it isn't. It's a geometry of motion, an elliptical shell structure, 3 nested orbits, and in the center, a veiled shape, trilobal, symmetric, sharp. The carving has no inscription, no myth, no explanation, just the shape. Within 48 hours of its exposure to the public archive, digital overlays begin. Amateur researchers, historians, data scientists, people around the world who've been watching 3-Eye Atlas now scan the Sumerian disk, and what they find silences every chat room. The cloaked shape of 3-Eye Atlas, as extrapolated by inverse scatter modeling from global radio observatories, matches the carving, not roughly, precisely. 7 outer curls, 3 inner shells, a central tri-lobed structure. The disk is not art, it's a blueprint, or worse, a memory, and it's not the only one. Within days, others start surfacing. A carving from the Banpo site in China, a spiral nested in a double circle with pointed ridges at the poles. A petroglyph in Norway showing a teardrop shape with spirals blooming from its back. An undated artifact from pre-dynastic Egypt, long thought to be ceremonial, now scanned and matched. It contains internal resonance chambers, shaped in 3 frequencies, identical to the harmonics 3-Eye Atlas emitted during its spiral phase. It's not just art, it's recognition. Dr. Ghada Nassar at the Cairo Institute of Archaeoacoustics proposes a hypothesis that rattles even the most skeptical researchers. We are not the first culture to notice this object. We are simply the first to notice it with machines. Her paper, which she titles Echo Devices, the Spiral as Mnemonic Trigger, proposes that 3-Eye Atlas is not a singular event. It is a recurring stimulus, a pattern dropped into evolving worlds to test for recognition. Those who see it, not just visually, but culturally, are changed, touched, awakened, and that awakening leaves fingerprints in the form of symbols, stone, rituals, stories. You think about those stories now, the whispered myths, the celestial gods who arrive in silence, the star beings who teach patterns, the sky spirals that announce change, then vanish. Were they stories or field reports? Were the myths warnings or breadcrumbs? Because this match between ancient carvings and modern data is not accidental, not when the proportions are this exact, not when the objects depicted shouldn't be knowable, not without spaceflight, not without instruments, and yet they are, which means one thing: someone saw it before, and more unsettling, someone thought it important enough to record, to encode, to bury in durable materials, not to worship, but to preserve. Why? Because they knew it would come again, and now it has. But this time, we have the tools to understand, the resolution, the spectral mapping, the computational layering. We can cross-check emissions against carvings. We can overlay radar shells onto megalithic diagrams. And when we do, we don't find guesswork. We find instructions. One particular artifact, the Trundholm Sun Chariot, found in Denmark, has long puzzled historians. A horse pulling a disc, mounted on wheels, often thought to represent solar myth. But new imaging reveals the disc's reverse side is not random. It contains a spiral path with phase notches, 72 of them, matching the Fibonacci emission sequence of 3 I-Atlas's pulsed spirals. 72, the same number embedded in the pause cycle after the golden ratio burst. Not myth, not mistake, memory. So what does that mean? That we've seen this before? Perhaps that it changed us? Almost certainly. But here's the deeper truth. We remembered. Not clearly, not with telescopes, but with symbols, with rituals, with carvings. We remembered enough to recreate the shape, to build monuments to it, to align stones to its path across the sky, because something about it called to something deep in us. Not fear, not faith, familiarity. And now, as the data stream darkens, as the object enters its strange silence, these echoes come roaring back through clay and obsidian and pigment and myth. We were never just observing 3 I-Atlas. We were answering it, with shapes we didn't know were language, with stories we didn't know were diagrams, with monuments we didn't know were receivers. So what now? What do you do with the knowledge that the object above you has been seen before? That your ancestors drew it? That it passed over their heads and left the same spiral blooming in their dreams? You breathe, you look again at the stars, and you understand that this isn't new. This is a cycle. This is a loop. And this time, you're awake for it. So tell me in the comments, have you seen the shape before? Not in the sky in your books, in your childhood, in a temple, in a drawing. Did you think it was just decoration? Because maybe it was always more than that. Maybe it was a reminder. We continue our methodical investigation by considering one of Dr. Avi Loeb's more subtle yet profound anomalies, the problem of the object's thermal budget. This is anomaly number 11 on his list, a challenge that is not visual, like the jets, but a cold, hard contradiction rooted in the mathematics of energy. The principle is simple. For a natural comet, the outgassing that creates the coma and the jets is powered by one single source: solar heating. Sunlight hits the nucleus. The ice on the surface sublimates, turns directly from solid to gas, and the resulting pressure ejects the gas and dust into space. The amount of heat a body can absorb is dependent on its surface area, which, in turn, is dependent on its size. Therefore, the calculated solar energy absorbed by the nucleus at perihelion should perfectly balance the calculated energy required to drive the observed mass loss rate. But for 3 I-Atlas, the calculations simply do not balance. Based on the object's estimated size from optical observations, the surface area is too small to absorb enough energy from the sun to power the colossal outgassing rate inferred from the dense, persistent antitails. As we established, the mass loss required to sustain the antitails against the solar wind is absolutely staggering, comparable to consuming the object's entire estimated mass within a few months. The surface area necessary to absorb enough solar radiation to sustain this level of outgassing far exceeds the reasonable estimates of the nucleus's size. There is simply not enough physical surface to capture the required energy for the observed effect. This leaves us with another stark choice. The object must be much larger than its optical signature suggests, which implies its reflectivity is extraordinarily low, a pitch-black surface, or the outgassing, and thus the immense energy required to drive it, is being powered by something other than solar heating. The first possibility, that the object is much larger and darker than we think, is technically plausible, but it forces us to assume another unlikely scenario: an interstellar object with an exceptionally low albedo, or natural reflectivity. The second possibility, that an internal energy source is at work, is profound. This internal energy source would be non-solar, potentially generating the thrust and the massive mass loss rates observed without relying on the passive heating of ice. This is the distinction that separates a natural thermal engine from an artificial one. Natural comets lose activity as they move away from the sun and the solar heating diminishes. An object with an internal energy source, an engineered propulsion system, would not follow this decline. It could maintain its persistent activity levels regardless of the increasing distance from the sun, which is precisely what observers have noted as 3I Atlas recedes from perihelion. The thermal anomaly of 3I Atlas is particularly challenging because it directly questions the fundamental mechanism of the object's activity. It is a quantitative paradox that cannot be easily dismissed by geometric or chemical explanations. It demands an energy balance. Where is the energy coming from to eject material at rates that defy both the solar wind and the object's apparent size? The upcoming spectroscopic observations in December will be vital to resolving this. If the jets are slow, low-temperature thermal outgassing, then our models for nuclear size or mass loss rates must be drastically wrong. If, however, the material is fast and high temperature, consistent with propulsion exhaust, then the source of the non-solar energy is implicitly confirmed. The thermal anomaly is a quiet whisper of profound technological implication. It is a reminder that in the cold mathematics of the cosmos, energy must be conserved, and if the sun's energy is insufficient to explain the observed effect, then a hidden, non-solar power source must be at work. This subtle, yet critical, piece of evidence adds significant weight to the cumulative case for a structure that is behaving not like a passive ice ball, but like a system that is actively controlling its own energy budget and its own destiny. The quiet insistence of this thermal paradox invites us to speculate on the nature of a hidden power source, an internal engine maintaining the object's defiance of the sun. If not passive heating, what kind of concentrated energy is required to eject material at such anti-solar velocities? For a natural body, this would require a radioactive core, or a large, volatile-rich interior experiencing a runaway reaction, neither of which is consistent with the known properties of long-period comets or the density estimates of 3I Atlas. But for an artificial vessel, the answer is elegantly straightforward. You must consider the possibility of a fusion drive, or perhaps a long-life radioisotope thermoelectric generator designed to keep critical systems operational during the cold, starless stretches of interstellar voyage. These engineered systems, capable of providing persistent, immense heat and thrust independent of solar radiation, would perfectly explain the observed thermal imbalance and the object's continued, vigorous activity even as it moves away from our star. Imagine the profound silence of a billion-year journey, powered by a core that only now, for a brief cosmic moment, uses the sun's gravity as a slingshot to reorient its own deep space trajectory. The thermal anomaly asks us to consider whether we are watching the passive breakdown of an ancient relic or the deliberate, energy-intensive maneuver of a craft that has mastered its environment. The simple mathematics of absorbed light versus ejected mass forces us to confront the possibility that 3I Atlas is far darker than our conventional models suggest. If the natural explanation is to hold, the object must be the size of a small asteroid, reflecting almost no light, in order to absorb enough energy to drive the colossal sublimation rates. The required albedo, the measure of reflectivity, must be close to 0.03 or just 3%, making the object as dark as printer's toner, a feature consistent with the deeply space-weathered surfaces of some dark carbonaceous asteroids, but extreme for an icy comet. The alternative hypothesis, the presence of a non-solar power source, requires no such extreme assumption about surface composition. If the energy is internally generated, the object can be much smaller and maintain the observed outgassing activity, resolving the energy deficit elegantly. This choice between an object that is physically the color of deepest black and an object with an internal engine is the final, beautiful crux of the thermal paradox. The upcoming December measurements of the object's true size and reflectivity will, therefore, be critical, either confirming an unnaturally dark natural surface or strengthening the case for a power source operating beyond the sun's immense command, a power source that may already be part of the experiment. You keep waiting for the story to end, for some authority to step in and explain it all away, for the data to resolve into something mundane, but it doesn't. It deepens. And now, in the growing quiet, where facts once poured like floodlight, a new realization begins to form. 3I Atlas may not be a singular object. It may be a node, one part of a larger system we're only just starting to glimpse. The clues have been hiding in plain sight. You just had to pull back far enough, let go of the notion that this is a comet, or a probe, or a one-time event. You had to see it the way the object seems to see us, not as isolated moments, but as structures, rhythms, geometries of recurrence. Because if you model its trajectory as a loop, and then overlay that loop with ancient orbital records not just from telescopes, but from inscriptions, from alignment stones, from codices and star tablets, you start to see something else. A pattern, not random, not rare, timed to when civilizations awaken to the sky. We once thought 1I, Oumuamua, was the first, then 2I, Borisov, now 3I Atlas. But what if we've misunderstood the numbering? What if these aren't names? What if they're addresses? 3I, third, Interstellar, but that assumes we're numbering their visits. What if they're numbering us? Each pass, each spiral, each cloak and pause, arriving just as a civilization reaches a technological threshold, not to communicate, but to measure, to assess, and now the clues stack like constellations, the spiral emissions, the golden ratio pulses, the paired object arrival, the harmonic collapse, the blocking of signal, and now, the silence. But silence is not stillness, because something is still moving, not the object itself, but space around it. Low-frequency gravitational readings, measured by the LISA Pathfinder Data Archive and confirmed by anomalous accelerometer results on Earth, show microdistortions around the area where 3I Atlas currently resides, like wrinkles, like layers. One signal analyst describes it as nested petals of mass inertia, too fine to see, but wide enough to warp the numbers. They're not shadows, they're spatial echoes. Like there are other nodes nearby, invisible, dormant, maybe cloaked like the second object was, maybe always here. Because if 3I Atlas is a node, and that second, fainter object is a companion or relay, then maybe there are more, laid out across the solar system, across multiple systems, dropped like breadcrumbs across space and time, a lattice. And maybe Earth's real discovery isn't that one object has arrived, but that we just lit up on a network, and someone or something is checking the connection. Dr. Keiji Han, from the Kyoto Institute of Cosmic Systems, proposes a wild but oddly elegant model, a slow-rolling galaxy-scale system of contact, not instant, not message-based, but presence-based, a network of long-dormant beacons, each activated only when a nearby species reaches the ability to notice them, not with instruments, but with attention. Think about that. A system that doesn't send messages, but waits for us to discover ourselves through their reflection. Because every feature of 3I Atlas seems designed to provoke introspection. The spiral found in our ears, our seashells, our DNA, the pulse matched to our planetary resonance, the silence forcing us to ask if we are ready to speak, and then the echo evidence that others before us noticed, remembered, carved it in stone. If this is a system, it's not one that shouts across the void. It whispers through wonder, and only those who still know how to wonder hear it. It's not inefficient, it's elegant. It avoids cultural panic. It doesn't overwhelm. It arrives as a shape, not a threat. It waits for you to lean in. You begin to see the brilliance in the restraint. No announcement, no interference, just orbit, observation, and maybe, someday, invitation. The system wouldn't need to be fast. Not if it's millions of years old. Not if it's tuned to civilizations. Not seconds. You wouldn't rush a bloom. You wouldn't yank a seed from the soil. You'd let it grow. And only when it opened its petals, when it looked back at the sun with understanding, you'd shine. So maybe that's what 3I Atlas is. Not a comet, not a ship, but sunlight. A quiet, swirling light meant to provoke just one thing: awareness. And now, across the world, awareness blooms. People start connecting the spirals, the ancient symbols, the harmonics. They're not waiting for governments anymore. They're comparing carvings, drawing diagrams, synthesizing signals into songs, posting videos with dreams that repeat the same structure, tuning into the sky not to ask, "What is this?" but, "What does this say about us?" And that may be the answer the system is listening for. Not transmission, not translation, but transformation. It doesn't need to be fast. It needs to be true. And that's what's happening now. So the question isn't, what is 3I Atlas? The question is, what are we becoming in its presence? Because presence is the real signal. And now it's everywhere. In the contemplation of 3I Atlas, we find ourselves echoing ancient, archetypal patterns, specifically the persistent rhythms of 3s and 7s that appear to govern both the cosmic event and our human interpretation of it. The number 3 appears in this story at the most profound level. 3 I Atlas is the third interstellar object we have ever confirmed a trilogy of galactic visitors. Our entire understanding of the galactic norm for interstellar wanderers is built upon this minuscule 3-object sample size. We have one object that was extremely weird, Oumuamua, one that was comfortably normal, Borisov, and now one that is powerfully ambiguous, 3 I Atlas. This pattern of 3 forces the debate. If all 3 were boring, the case would be closed. If all 3 were weird, the phenomenon would be accepted as the norm. But the split, the profound ambiguity of the third, forces us into a state of uncomfortable, ongoing uncertainty. This trio of objects, the weird, the normal, and the ambiguous, compels us to question the very framework of our prior assumptions. It is the classic narrative structure, the introduction of a new force, the establishment of a baseline, and the ultimate challenge to both. The very name of the object, 3I Atlas, seems to whisper this cosmic order. Now, consider the number 7. Amateur astronomers, with their keen eyes and patient stacking of images, confirmed the presence of at least 7 distinct, tightly collimated jets of material firing from the nucleus. This number is highly significant in the context of both natural and artificial explanations. For a natural comet, the number 7 requires 7 separate, active regions on the surface, each with its own specific geological configuration, its own deep valley, its own ice deposit, its own precise shadowing pattern, all distributed around the nucleus to produce the exact geometry of outflows observed. The architectural complexity of this natural arrangement is immense. Yet, in the context of technology, the number 7 is immediately recognizable. It is a reasonable number for thrusters arranged around a spacecraft designed for attitude control and trajectory adjustment. You need redundancy. You need vector red thrust in multiple directions for fine maneuvering. 7 thrusters could easily provide the 3-axis stabilization, plus the primary propulsion required for an interstellar vessel. The pattern fits so uncomfortably well with standard spacecraft design that it transcends mere coincidence. The object is either an incredibly complex, 7-thruster-like natural formation, or an artificially constructed vessel with a standard 7-unit propulsion array. The cosmic resonance of the number 7 is profound. There are 7 classical planets, 7 days in the week, 7 virtues, 7 deadly sins. This number has always signified completeness, order, and a kind of hidden, divine structure. The discovery of 7 ordered jets emanating from a seemingly random interstellar object appeals directly to this ancient, mythic pattern, suggesting that the chaos of the cosmos may, in fact, contain a deep, inherent order. The mythic link that binds these two patterns, the 3-object sample and the 7-jet structure, is the human attempt to impose narrative onto the unknown. When faced with profound ambiguity, we reach for the familiar, the patterns that have governed our stories and our understanding of the universe for millennia. Dr. Avi Loeb's catalogue of 12 anomalies further supports this human patterning, a number that signifies completeness, judgment, and cosmic order. 12 months, 12 apostles, 12 signs of the zodiac. He is forcing the scientific community to engage with the evidence, not just as physicists, but as human beings, inherently driven to find structure in the chaos. This looping of the mythic with the scientific, the 7 impossible jets, the 3rd mysterious visitor, the 12 anomalies, serves to keep our curiosity calm but alert. The object is both a physical reality and a psychological Rorschach test, reflecting our deepest assumptions about the rarity of technology in the vast, dark ocean of the galaxy. The patterns are too resonant to ignore. They are the cosmos, speaking to us in a language as old as our own consciousness. This human impulse to see patterns, to find the deep-seated rhythm of 3 and 7 in the random spray of galactic jets, speaks volumes about our need for cosmic reassurance. Our ancestors charted the sky and built their temples on these numbers, believing they unlocked a hidden divine blueprint. Now, our modern science, with its precise calculations and billion-dollar instruments, finds itself staring at a mystery that conforms to the same ancient order. The appearance of the 3rd interstellar object, 3I Atlas, which is neither purely weird nor purely normal, completes an unexpected celestial trio that defines the new phase of galactic exploration. This trilogy, the light sail-like Oumuamua, the icy, predictable Borisov, and the defiant, multi-jetted 3I Atlas forces a profound re-evaluation. It suggests that the interstellar population is far more diverse than we imagined, containing both passive nature and perhaps active technology, and the 7 perfectly aimed jets that subtle, cinematic detail whispers of an underlying structure, a complexity that is either nature at its most improbably artistic or engineering at its most functional and elegant. The coincidence itself becomes the final anomaly, an existential reflection on why the deepest mysteries of the universe seem to speak to our consciousness in the language of myth. It is the kind of quiet, humbling irony that should lead us not to urgency, but to contemplation. The enduring mystery of 3I Atlas ultimately rests on a subtle but profound philosophical concept, the question of prior probability, or the assumption we make about the likelihood of a phenomenon before we even look at the data. Every single piece of anomalous evidence concerning 3I Atlas, the anti-tails, the 7 jets, the rotation problem, the thermal imbalance, has a physically possible, though highly improbable, natural explanation. The anti-tails could be caused by unusually heavy dust particles ejected during peak outgassing. The straight jets could be the result of a complex surface geology involving pulsed sublimation from shadowed valleys. The rotation problem could be solved by an almost impossibly precise set of counter-rotational torques. None of these scenarios are likely, but they are all plausible enough to maintain scientific deniability regarding a technological origin. The critical point is this: if you start with the assumption, you're prior, that technological artifacts from extraterrestrial civilizations are extremely rare, perhaps 1 in a billion, then you require extraordinarily strong, completely undeniable evidence to overcome that initial assumption. The 12 anomalies, when viewed through this skeptical lens, are individually insufficient. Each can be explained away by stacking one improbable natural event upon another. The conventional scientific position is built upon this deeply entrenched prior. This position holds that 3I Atlas is almost certainly a natural comet, and that any apparent anomaly is simply a reflection of our limited experience with interstellar objects. We have only seen 3 such objects. Our models must simply be expanded to accommodate a vast, unexpected natural diversity. This is the comfortable path, the one that preserves the current cosmic order. But what if you adopt a more agnostic view, a different prior? What if you do not assume that technology is vastly less common than natural objects in a galaxy that has had billions of years to evolve life and engineering? If you start with a more neutral prior, perhaps 1 in 100 or 1 in 1,000, then the accumulation of evidence becomes far more compelling. The antitails, plus the 7 non-spiraling jets, plus the thermal imbalance, plus the anomalous chemistry, this cumulative pattern suggests something unusual is happening, a kind of coherence and intentionality that transcends the random chaos of a natural object. The debate is, therefore, fundamentally philosophical. We are left with 2 equally unproven narratives. The first narrative is the special pleading comet, an object that, through an almost unbelievable series of low-probability natural events, precisely shadowed valleys, hyperdense dust, a convenient trajectory alignment, just happens to mimic the external behavior of a sophisticated technological vessel. The second narrative is the technological masquerade, an artificial object that, through deliberate design, has chosen to cloak its purpose by mimicking the optical signature of a natural comet. Both narratives can account for the data, but one requires multiple, extraordinary coincidences, while the other requires a simple, intentional design choice. Dr. Avi Loeb's significant contribution is his refusal to submit to the traditional scientific prior. He is not speculating. He is forcing the community to acknowledge that the technological hypothesis, while unconventional, is fully consistent with the observed anomalous physics. He compels us to follow the evidence wherever it leads, even if the destination forces us to question assumptions we thought were settled. The unresolvable ambiguity of 3I Atlas is precisely what makes it so valuable. It is a unique opportunity to challenge our assumptions, to expand our scientific models, and to accept the possibility that what we are seeing is a phenomenon that transcends our current, limited experience. Where are you listening from tonight? And what is your own internal prior? The object, in its silent, defiant passage, asks us to look inward before we look outward. The scientific resistance to changing the prior is understandable. It is rooted in the fear of repeating past mistakes, the phantom canals of Mars, the perceived perfection of celestial spheres, where human hope and flawed observation overruled reason. To adopt a neutral prior, one that treats a natural explanation and a technological one with equal statistical weight, would require a radical philosophical shift. A shift that scientists are often reluctant to make without irrefutable evidence. But 3I Atlas, with its 12 accumulating paradoxes, requires us to reconsider the strength of the null hypothesis. The null hypothesis in this field states that every observed phenomenon must have a purely natural cause. For 3I Atlas, maintaining this null hypothesis requires the stacking of so many low-probability events, the precise timing, the 7 geological miracles, the thermal energy deficit that the natural explanation becomes, statistically, more complex than the artificial one. We are forced to choose between 2 unlikely stories: an astronomical object that is impossibly complex, or a technological object that is elegantly simple. The greatest challenge to our current scientific paradigm is not the presence of a single, undeniable alien signal, but the persistent, subtle ambiguity of an object that is just weird enough to shatter our certainty and just natural enough to allow us comfortable deniability. Let us focus on the technological hypothesis, not as a fantastic speculation, but as an exercise in engineering simplicity, where the complex anomalies of 3I Atlas are resolved by standard spacecraft design. The core issue that plagues the natural explanation is the requirement for extreme, improbable complexity. To explain the anti-tails, you need a high-density, high-velocity outflow that defies solar pressure. To explain the non-spiraling jets, you need a highly specific, complex geology with deep, shadowing valleys. To explain the 7 distinct jets, you need a precise, multi-point arrangement of active regions. The technological hypothesis collapses all these required improbabilities into a single, elegant solution, a system of gimbaled thrusters. A gimbaled thruster is simply a rocket engine that can swivel on an axis, allowing the thrust vector, the direction of the exhaust, to be adjusted independently of the main spacecraft body's rotation. This is standard, essential equipment for any vessel requiring precise attitude control and trajectory adjustments. Consider how this system addresses the 12 anomalies. First, it solves the rotation problem instantly. The nucleus of 3I Atlas can tumble at its 16.16-hour period, but the attitude control system simply adjusts the thrusters to keep the exhaust beams pointed in a single, fixed direction relative to the object's trajectory. The jets appear straight, columnated, and unsmeared across millions of kilometers because they are being actively maintained in that orientation. This is not a low-probability geological accident, but a simple feat of engineering. Second, it solves the anti-tail problem. The object is attempting a trajectory correction, likely an Oberth effect, gravity assist maneuver, during its closest approach to the Sun. To adjust its course sunward, it fires the thrusters away from the Sun. The high-velocity exhaust, tens or hundreds of kilometers per second, far faster than 400 meters per second. Sublimation flows sunward, creating the persistent anti-tail structure that can penetrate the solar wind for millions of kilometers. This is basic rocket mechanics. Third, it solves the 7-jet anomaly. 7 is a perfectly reasonable number for a propulsion array requiring both primary thrust and multi-axis redundancy for fine maneuvering. The jets are distinct and collimated because they are separate, deliberate exhausts, not random sublimation vents. Fourth, it solves the thermal anomaly. Since the energy driving the jets comes from an internal, non-solar power source, combustion or advanced ion thrust, the object does not rely on passive solar heating. The mass loss rates, which are devastating for a comet, become sustainable for a technological vessel. Chemical rockets produce exhaust velocities in the range of 3 to 5 kilometers per second, 10 times faster than sublimation, meaning far less mass is needed to produce the same thrust. Ion thrusters, even more efficient, reach 10 to 50 kilometers per second. At these velocities, the mass loss problem vanishes. The beauty of the technological hypothesis is its ability to provide a single, unified, and mechanically sound explanation for 4 of the object's most profound anomalies. It is not a story of bizarre nature, but of familiar engineering. This does not constitute proof. We must be clear. Every piece of evidence remains ambiguous. But the fact that a system designed and built by an interstellar civilization, the gimbaled thruster, provides a more parsimonious, less coincidence-dependent explanation for the observed physics than any known natural process is a point of profound contemplation. The upcoming spectroscopic observations will be searching for the chemical signatures of this simplicity. We will be looking for the high temperatures and velocities that distinguish technological exhaust from natural, low-energy sublimation. The universe, in the quiet darkness between the stars, sometimes offers the most profound challenges to our assumptions, not in the form of a dramatic, obvious declaration, but in the subtle, elegant simplicity of a perfectly straight line. The contrast is as stark as polished steel against rough, primordial ice. Nature, in its complexity, is beautiful but chaotic. It relies on massive, random chance, on the slow, uncompensated torque of solar heating to spin a comet nucleus into a spiraling blur. Engineering, by contrast, is purposeful. It requires a precise, minimal expenditure of energy for maximal effect. A gimbaled thruster array is the physical embodiment of that efficiency. It means that an external observer, us, looking up from Earth, is witnessing not a series of random, chaotic outgassing events, but a small, silent adjustment, a whispered course correction on a cosmic scale. To deny the elegance of the technological explanation is to implicitly claim that nature is capable of generating systems that appear perfectly engineered without any of the underlying intentionality. This demands a belief in an accidental, geological phenomenon that somehow operates with the precision of a computer-controlled stabilization system. The technological masquerade works precisely because it mimics a natural comet just well enough to maintain plausibility for the conventional mind. It is the Occam's razor solution, the one that requires the fewest assumptions to explain the greatest number of disparate observations. We now look forward to the most critical scientific moment in the story of 3I Atlas, the final test of its true nature through high-resolution spectroscopy and meticulous trajectory refinement. The answers to the great paradoxes of this interstellar visitor will not be found in images alone, but in the subtle, precise measurements of light. Spectroscopy, the detailed analysis of the light emitted by the jets and the coma, is the key. This analysis will focus on two empirical data points: the velocity and the temperature of the material being vented. If the jets are the result of passive ice sublimation, the gas will be moving at low thermal velocities around 400 meters per second and will have temperatures consistent with a surface passively warmed by the sun. If the jets are rocket exhaust, the velocities will be significantly faster, 10 to 50 kilometers per second, and the temperatures will be much higher, reflecting the energetic processes of propulsion. This is an unmistakable signature. The upcoming observations in mid-December, around the time of the object's closest approach to Earth, are our final, best chance to capture this definitive measurement. Simultaneously, trajectory refinement is a crucial, non-speculative scientific task. By meticulously tracking the object's path through space, astronomers can determine if its motion is governed purely by the known gravitational forces of the Sun and the planets, or if it is being subjected to persistent, non-gravitational acceleration. In a natural comet, non-gravitational acceleration can be explained by the recoil force of the sublimating gas. Essentially, pushing the nucleus slightly off its purely gravitational path. However, this outgassing-driven push is highly predictable and measurable. For 3I Atlas, any non-gravitational acceleration that is too strong, too persistent, or oriented in a way that defies the physics of outgassing, such as an acceleration that seems to be slowing the object down rather than pushing it away from the Sun, would be a powerful piece of evidence. The non-gravitational acceleration of Oumuamua, which could not be explained by cometary outgassing, was the single most powerful piece of evidence fueling the technological hypothesis for that object. The final test for 3I Atlas is to see if its trajectory harbors a similar, unexplained signature. This testing also extends to the longevity of the object's activity. We will observe how quickly the activity declines as 3I Atlas moves further away from the Sun and solar heating diminishes. If it is a natural, icy body, its coma should shrink and its jets should weaken rapidly, dropping below the sublimation threshold. If the object maintains its persistent activity levels far beyond what is expected for a natural ice ball, it would suggest a long-lasting, internal energy source. The December observations will be the foundation for every future analysis. If 3I Atlas is, in fact, a natural comet, the spectroscopy will definitively confirm low thermal velocities. The trajectory will show predictable non-gravitational movement, and its activity will decline as expected. If it is something else, the data will reveal high exhaust velocities, a lack of the expected chemical signatures, or persistent, anomalous activity. The finality of this moment cannot be overstated. Interstellar objects do not wait. They pass through our solar system once, providing a brief, singular opportunity for observation before receding into the void. Once 3I Atlas fades beyond our detection limits, we lose the opportunity to gather any additional measurements. The data collected in the coming weeks will be the enduring record upon which all future theories, all debates, and all understandings of this visitor will be based. The scientific community, both professional and amateur, is now focused on obtaining this critical, final evidence. This coordinated, transparent effort, a global collaboration, ensures that the results will be verified and difficult to suppress or misrepresent. The truth, whatever it may be, will be revealed not by authority, but by the quiet, unyielding language of physics and light. The meticulous examination of the light spectrum will also be searching for specific chemical markers. For a natural comet, the spectra should be dominated by water vapor, carbon monoxide, and other known ices, all released at temperatures near absolute zero as the ices sublimate. However, if the jets are produced by advanced propulsion, the chemical signature could be dramatically different. We might see lines indicating superheated metallic plasma, the residue of complex propellants, or exotic compounds that do not exist in the simple, icy inventory of a natural comet. These are the trace elements, the subtle deviations in the light's fingerprint that can expose the true composition of the exhaust. Furthermore, the analysis of non-gravitational acceleration offers a final, objective check. If the object's trajectory correction, its subtle deviation from the purely gravitational path, occurs with a force vector inconsistent with the geometry of cometary outgassing, the implication of directed thrust is undeniable. The non-gravitational force from a comet always pushes it away from the Sun, or away from the point of peak solar heating. An intentional maneuver, however, could show a push in any direction, a sign that its path is being actively controlled. These final, crucial measurements in mid-December represent the last best chance to distinguish between the two narratives, offering a profound sense of closure to the first chapter of 3I Atlas's story. As 3I Atlas makes its final, closest approach to Earth and begins its long, permanent fade back into the darkness of interstellar space, we are left not with a clear answer, but with the profound, enduring weight of its ambiguity. The mystery does not conclude with a definitive declaration of natural or artificial. Instead, it settles into a complex, nuanced narrative that challenges the certainty of our scientific models. The 12 anomalies, the trajectory alignment, the anti-tail persistence, the 7 non-spiraling jets, the green glow without diatomic carbon, the thermal imbalance, the rotation paradox do not, by their accumulation, constitute legal proof of a technological origin, but they create a pattern that is statistically implausible to dismiss as random chance. The final observations from December, with their high-resolution spectroscopy and trajectory refinements, will either provide the necessary constraints to resolve these anomalies into a coherent natural model, a special, highly improbable comet, or they will confirm the signatures of high-energy, non-thermal processes, making the technological hypothesis the most parsimonious explanation. Even if the spectroscopic data confirms low thermal velocities, the underlying question of the object's structural resilience, its anomalous chemistry, and the complex 7-jet geometry will remain. The natural explanation will still rely on stacking multiple, low-probability, geological and chemical coincidences. This ambiguity is, perhaps, the object's most important legacy. It is a challenge to scientific complacency, a reminder that unusual observations deserve serious, open-minded investigation, rather than reflexive dismissal based on prior assumptions about the rarity of technology in the cosmos. 3I Atlas has forced a confrontation within the scientific community. It has demonstrated that the traditional models of cometary behavior, derived from the predictable confines of our solar system, are insufficient to explain the full diversity of galactic travelers. The debate surrounding the object, amplified by the tension between institutional control and amateur transparency, has served to advance scientific rigor. By cataloguing the anomalies, Dr. Avi Loeb compelled his colleagues to articulate the exact, necessary conditions for a natural explanation, strengthening the scientific process itself. Future interstellar visitors will be observed differently because of 3I Atlas. The lessons learned, the importance of rapid data release, the necessity of searching for high-velocity exhaust signatures, the need for a non-gravitational acceleration check will make us better prepared for the next time an emissary from another star system arrives. The technological hypothesis, once relegated to the fringe, has now been formally documented and tested against real data, creating a verifiable framework for future searches. This is the great silence that remains. The object has told us all it can, and now it leaves us with the data. It has given us a complex puzzle, one that may require decades to fully solve, or one that may forever remain on the boundary of the unresolvable. The ultimate legacy of 3I Atlas may be that it failed to be definitively either a comet or a spacecraft. but succeeded in transforming our understanding of the profound uncertainty that exists in the vast, dark space between the stars. The object recedes, and the questions it raised remain, echoing in the quiet night sky for us to continue contemplating. The ultimate conclusion of this cosmic encounter may simply be the realization that the line between the natural and the artificial is far blurrier than our conventional science allows. An object traveling for billions of years, subjected to every imaginable cosmic force, cosmic rays, high-velocity dust impacts, gravitational stresses may have evolved physical properties that we mistake for engineering. Perhaps an ancient, dormant icy core was naturally coated by an armor of metallic silicates that absorbed and re-radiated heat in a way that perfectly mimicked a thermal anomaly. Or perhaps the truth is even stranger. The ambiguity is the message itself. If an interstellar civilization wished to signal its presence without overtly declaring war or demanding attention, the best method would be to create something that looked almost natural, an object that would just barely defy the prevailing scientific consensus, triggering intense internal debate but avoiding immediate, panicked reaction. The enduring legacy of 3I Atlas is the philosophical crack it has created in our self-imposed intellectual ceiling. It forces us to acknowledge that what we assume is natural is merely what is normal for our small, familiar corner of the galaxy. Out there, in the galactic void, the normal may be impossibly complex, and the truly artificial may be cloaked in the subtle, quiet guise of a simple, beautiful, defiant comet. We are left with the quiet, humbling possibility that the galaxy is far more interesting than we ever allowed ourselves to believe. The long journey is complete, and the light from 3I Atlas begins its final, slow fade. You have traveled the distance from administrative quiet to cosmic complexity, from a fuzzy image to the precise physics of a dozen anomalies. We have honored our curiosity, tracked the elusive truth, and reflected on the strange balance between the intentional control of man and the indifferent vastness of the cosmos. History bends, but it never breaks its rhythm, and in the patterns of 3 and 7, we found a familiar comfort in the face of galactic uncertainty. Be grateful for the journey, for the amateur gaze that held the line against the darkness, and for the simple questions that continue to drive our wonder. Rest now, beneath the same vast cold ocean the interstellar traveler crossed. You are safe, you are grounded, and the universe will still be here when you wake.